Ladies and gentlemen, let me take the opportunity to now introduce a panel of technical experts coming from 3D technology in terms of the offering the solutions in the space. I think morning we had a very detailed discussion on, and we were very privileged to have Shri Amitabh Kumarji, who is a DG shipping, and he's also awaiting our response going back, our response in terms of the recommendation of how maritime and shipbuilding can be taken serious note of the 3D technology going forward. And also, subsequently, we had respondents share insights on classification of these parts, registration, certification, all of that. And then also two of the leaders who are also in the service business, one from Williamson Ship Services, based in Singapore, and also L&T Defense, who is also actively looking at offering solutions in this space. So in times to come, maybe in a month, there will also be a full-fledged center offering solutions in aerospace, defense, maritime, and shipbuilding too, and various other opportunities that probably we will be looking at from them. So thank you so much. And now we would like to introduce you to Rajesh Mrityunjan, who is the Vice President with Monotech Systems, who is also an expert in 3D technology and also an engineer by background. And he's been in the space for almost last 1 decade, offering solutions in the space. And Monotech Systems have actually evolved as a company, as a one-stop solution for them with various different product line to offer. So I think it will be a great mix of technologies that they will want to offer the community going forward. So great, Rajesh, for having you a part of this session, and maybe also have to know and get to know all the technologies that you are in the offering. Thank you so much, Rajesh. You can have your presentation on.
Thank you, Shibu, for this wonderful opportunity. And believe me, this is going to be a learning session for me because, like a few others, I am also not from this background, but I have been in the large capital equipment market and projects business to understand that the difficulties which we went through in our times with the conventional manufacturing and how this could be a very good boon for us. And the reason I moved into additive manufacturing from the project business was to make use of this technology for the larger projects. And I guess maritime and shipbuilding is one of them. And I heard the eminent guests and sponsors and the specialists early in the morning talking about this, how the shipbuilding and the challenges which are there, and how this additive manufacturing could be useful. And well, I will not go into too much of details on the maritime and shipbuilding because that is something I would like to learn. But surely, I would like to show what we can do in this technology and with additive manufacturing and 3D visualization today with respect to maritime and shipbuilding. The agenda will be very close to about us, will be in the last value proposition. We'll just talk about the value proposition, what additive manufacturing we bring into for this industry, and which will contain the 3D scanning and reverse engineering, rapid tooling and manufacturing. And of course, we will conclude with the way forward. As we know that half of the world's manufacturing equipment will be replaced in the fourth industrial revolution. I heard few guests mentioning that we have not been in the three revolutions with respect to shipbuilding here, but we are very it's like we are getting into the fourth revolution directly with these technologies, and I guess shipbuilding and maritime will be very much it will be a great opportunity for getting into additive manufacturing and the fourth revolution with these applications. So we believe that this is going to be the future and it is going to stay, but it also depends on which application, which technology has to be suited. So this is where we would like to provide a value proposition of AM in maritime shipbuilding. So we would like to break it down into a few things like what is the value proposition of AM in maritime and shipbuilding. If we have been listening to metal technologies, metal printing, but there are other technologies as well, which could probably provide a value proposition to the maritime and shipbuilding. But when we break it down to the basics, we talk about lower costs, which is the very much requirement of any industry today. Probably not for aerospace, but for others, even for maritime and shipbuilding, the requirement of lower cost is very, very important, which can be classified in products, the clarification, what is required, and supply chain. And so the products, we will have to go for less material and no tooling or cheaper tooling. So this is what will give us lower costs, and the supply chain it will result into a less transportation and less warehousing, as we heard Dr. Ashok Verma saying that the warehousing and less transportation is going to be resultant of this additive manufacturing, which is going to have localized manufacturing. We are talking about better designs. So complexity for free, different materials or multi-material options, optimized integrated functionality and part consolidations. So these are all things which are the basics for additive manufacturing in any industry. And this will be the beginning of additive manufacturing into any industry. And this will further go into manufacturing and rapid tooling, etc. So then we talk about also the customization in terms of aesthetics and quick change of design and reverse engineering. So further, we talk about sustainability and then the business modules. So when we talk about business models, it's basically prototyping, small series, and reduction of operations. So while we talk about the end parts, the end use, we should also be thinking about how we can start with additive manufacturing with respect to prototyping and probably get into the small series of manufacturing. So with these value propositions, the transformation journey is very clear for us, right from the conventional mode of manufacturing, where the current operations of the maritime is with the cutting, plate bending, welding. We are talking about additive manufacturing being introduced or to be introduced in these manufacturing processes, which reduce the overall time and also reduce the costs and optimize the overall the process. And the ideal AM process would be that you have just the input, the operations, which is the additive manufacturing process, and output. But where are we today is basically in a hybrid system where we would be having the additive and the subtractive working together to reduce the overall operational and process and the costs. So to sum it up, what we talk about with respect to 3D printing, which can help the maritime and offshore industries, is improving the spare parts manufacturing. And those who are getting obsolete, we have a lot of ships which are from Russia and other countries, but we do not have a lot of spares, and we do not have even the drawings at that time. So these are all obsolete parts, which if we could do some reverse engineering and we could print the parts, it would be actually very value for the whole value proposition. And then we talk about rapid prototyping of parts, replicating scale ships. So this is also important when we talk about the technology being implemented in manufacturing. We should also be talking about training and education, and which is very important to develop the team or develop the industry or industry experts from to understand the importance of AM in the industry. So for that, we need to have some sort of equipment models, scale ship systems, and detailed features, and etc., which can actually give us more understanding. And also, this can be utilized in training purposes. Smoothening the workflow flow and planning. Now, we talk about specific industries, specific applications, specific areas where we can use it. But we should also be talking about the process, where how we can use this technology to smoothen up the workflow and planning. How do we speed up the performance testing? How do we minimize the errors? And how do we reduce the warehousing space and cost? Now, when we ask these questions, additive manufacturing has an answer with a few solutions for these questions. And when we see on an overall ecosystem of maritime, we talk about cost reduction, we talk about time saving, we talk about environment friendly, we talk about less space and modern manufacturing. Now, additive manufacturing can bring about all this within the ecosystem, and which could be broken down into various other aspects like reducing delivery times. We could talk about replacing multiple parts assemblies with one 3D printed part, which is consolidation of part consolidation. We talk about. We could talk about less material on stock. Inventories are a big problem for any industry, including maritime, because we are holding large inventories of big parts which can be reduced. We talk about environment friendly, so we do not need for global deliveries. We can print locally. We can have less machines involved in the process. We can even do on-site, like so Varma was telling that requirement of having the machine right at the place where it is required, and that's something which is very important. Like you have a submarine, you cannot bring out certain parts to do the repair jobs or something. What if you can have a robot with a DED technology into the submarine to do that sort of operations? These are the boons which this technology can really bring about. Uh, and then we go into the further of what these value propositions mean and the technologies which can be utilized for this, which is scanning and reverse engineering. For example, we are talking about many components which are obsolete and or used by casting, produced by castings, and most of them it's very difficult to actually inspect them. So we could either inspect or reverse engineer, or we can do quality checks, periodical quality checks using scanning and reverse engineering. And a small video on this. Sorry. So, what if we have a ship which is not on the shore and it is mid sea and there is a problem and there is a part or a spare need to be replaced? But we know that it's going to take some few days or probably a month to come back. If the reverse engineering, scanning and reverse engineering could be done mid sea, and the part or the file can be sent to the store where it can be printed, and it is awaiting the ship as it comes shore, and it can be replaced immediately. The amount of time we can spend, we don't spend on waiting for the this to come and then raise the indent, and so many things are there. There are so many delays which can be reduced by having a scanning and reverse engineering into in the ships to help us. And this can also be used for intermediate like inspections when it is in mid sea to avoid any sort of catastrophe, and various other applications which can be thought across. And this is basically something which is fixed scanners. There are also handle scanners which are available in the market, which can help you scan larger objects or even large, say for example, this is an example of scanning a car. So similarly, you can have handle scanners which can scan larger objects easily, and that can be reverse engineered, or probably you can use it for some sort of inspections. So with such handheld scanners, large parts or large structures can be easily scanned, and they could be also reproduced as models, or rapid prototypes. And this is a very important part of additive manufacturing in the industry, because we normally neglect this part of it, because we feel that metal is of course metal is the future, or is the most important part of shipbuilding and maritime, because most of it is metal. But what we need also is planning. So for planning, we will need equipment models. We have to have accurate models which are as per the parts, and also rapid prototypes which can be developed. So these are also important parts of this industry. And also, we talk about technology being utilized, how polymer technology can be utilized for larger structures in sand casting patterns. This is a small video I would like to just show.
At CJAR, we manufacture stern gear for luxury yachts and workboats. We focus on the quality of our products, so every propeller has to be perfectly designed for the boat. So we tend to design every propeller bespoke to that vessel, so that it's perfectly matched. And in doing that, we need to produce new patterns for every propeller that we make. And the 3D printers have assisted us to make those patterns quickly and cost-effectively.
Since we bought the Big Rep printer, we're able to control the whole process of printing and manufacturing patterns, which means that we are far more competitive in the market.
This is another 3D print pattern. This is for a surface-piercing propeller, which is kind of, it's not fully submerged. It sits on the surface of the water, and for very high-speed boats. And again, this is something new that we wouldn't have been doing without a 3D printer, because it's so cheap and easy to make the patterns that we can experiment with many different designs.
With previous deliveries, it all went well with our pattern makers. We were talking weeks, now we're talking hours. And the other great thing for us is we can start the printing on a Friday night. We can let it run over the weekend, and then Monday, Tuesday we come in and we've got a pattern which we then do minimal work, a bit of filling, sanding, painting, give it to the foundry, and they're ready to work with it. So it's really cut our delivery time down considerably.
So this shows us how polymer patterns can be used for sand casting, and which is a big boon for the industry, where large patterns have to be made, and multiple iterations have to be done in order to test and finalize the best pattern or the best part. So we're talking about hours instead of weeks and months, and this was with you can talk about prototyping and patterns. We come to rapid tooling in maritime, where we talk about pattern making, and this is where metal printing is mostly utilized. And we talk about DED or powder bed fusion technologies, which are really in the way forward for this industry, where smaller tools or molds or dies can be made easily with the powder bed technology. But when you talk about larger patterns or larger molds and dies, we can utilize DED technology and LMD, which is a technology which is suitable presently because of its low cost in terms of investment and running, where you could use wire or powder or both to produce parts which were really not possible in the earlier stages. And it is also low cost, because you are utilizing welding wires which are available in the market easily, and also it is low cost to own and operate. So when we talk about maritime and shipbuilding, normally even the cost is an important factor. And when we come to manufacturing, naturally the cost is compared to the conventional manufacturing costs. And this technology really brings it to that level. And but it is also able to, produce complex parts the way you can see it right now. And when we go to the small batch productions, where we talk about, say for example, this is printed out of Big Rep, which is a plastic polymer based machine, where these sort of underwater scooters have been produced, and they're operational, which means that they are not just for prototyping, but they are operational. And almost 75% of the parts in this are printed, including the outer body and the internal structures. And this could be further, you can use composite printing, which can reduce the overall weight and increase the efficiency of these sort of boats. So this is something which we can think about for, say, rescue rafts or rescue boats, which are also part of the maritime and shipbuilding. And then, of course, this video was already shared earlier, but just to refresh memories, probably I'll just show. This is how you could do repair jobs, and 48 blades, which are made in few hours time to create this single piece axial compressor. So this is where rapid manufacturing is, and rapid, you can talk about repair jobs can be done very easily with using the Meltio technology. So I would just get into the brief overview of the metal AM technologies. We have been talking about various technologies, including DMLS, ADAM, which is close to metal injection molding. We have VAM, EBM, SLM, LMD. But overall, there are many variations, or the selection criteria depends on a lot of factors. And it depends on what is our priorities in terms of the selection of printing technology. And but today, as of today, when we talk about conventional versus pure AM versus hybrid, we really think that today we are in the hybrid mode, where hybrid manufacturing is the right choice for this industry, where while we use the conventional methods, the additive manufacturing can be integrated into this system. So there are a lot of advantages. The combined advantages are more than the individual ones, as you can see, between the additive and the CNC machining. And we are right here. We are in the hybrid system. We know that the APO AM could be the tomorrow, and traditional manufacturing was the past. Today is hybrid, and we are here with the technology. And we talk about the various type of energy deposition systems: laser-based, electron beam, plasma, or electric. And also they are further divided into powder-based and wire-based. So there are various models or various manufacturers or various technologies within DED which are available in the market. And the advantages of DED are far more than the other technologies put together in this for this industry, because of there is no size limitation basically, and the choice of materials is larger, and the printing or the manufacturing time is reduced. We can have faster printing, and since we are printing large parts, the accuracy is not as much as in automotive industries. So you could do with this technology with near net shape parts, which can be machined later on. You can go for multi-material range and easy material change. That's more important, because if you are printing one part for one component and you go back to tooling, you need to use another materials. It is very easy to change over. Disadvantages, of course, are high capital cost, low bit resolution, and no support structure. So if you're having XYZ sort of system, it's very difficult to remove the structures, because it's going to be solid supports. And hence the hybrid technology, where you use CNC or robotic integration, which can reduce the overall support structures, you will have more degrees of freedom. For all these disadvantages, Meltio has a solution, which is basically a low cost, compact, and it is a high capability and highly compact machine. It has got a standalone system, as well as it can use wire and powder together in the same system, in the same head. So which is a very big advantage for utilization of powder in very thin structures or very fine details, and wire for fast printing. And if you see that this is in the segment where every comparison, this actually stands out compared to the other technologies in this segment. So, the heat source also, when we talk about Melteo's lasers, they consume very less power, and they're easy to use, and they create lesser stresses for larger components. So it's very easy to use and very safe to use, in fact, system. And if you see LMD in terms of efficiency and ROI, for the efficiency it is almost in between. In the ROI, it is it's most productive, highly productive for the investment, low investment what you have to make in this. Integrations with CNCs and robots are possible with this, with the existing CNCs or with new CNC and any existing robots as well. So these are the benefits of DED technology. You can see all parts being printed very easily. The degree of freedom depends on the equipment which you are integrating this with, and that's the technology benefit you have. And you could actually replace these applications using this technology. And also we are talking about multi-material capability with the same machine, or you have dual wire system where you could use two different materials. And for those who think that okay, this is a rough structure, how does the output show after machining? You could get as good as the end nozzle which you are looking at right now. And so these are the components which are printed, and the range variety of materials is second to none in terms of additive manufacturing technologies. So I conclude here saying that the way things are being made is right from the left hand complex structure to the simplest way of creating a prototype or a product or a tool. And we, just to talk about us, we are a 22-year-old company with 400 plus employees, 6,000 plus happy customers with our wide range of sales and service centers all over India. And we are able to support various industries, including shipbuilding or government or defense, aerospace, different type of industries. We are having customers, and in 3D we are here for six years now. We have 10 own brands, 27 aligned brands, and our partnership and transformation what we have made is not based on just the product. It's based on the solution and application for the industries. And we work with almost all the materials, may it be polymer, metal, ceramics, thermoplastics, wax, composites, gypsum, and we have the in-house capability of even understanding your requirement and providing your solution. With this, I thank you very much for the opportunity, and I guess there's a lot to learn in this industry. Thank you very much, sir.
Thank you so much, Rajesh. What I have is, there is one question, and subsequently, participants, we would also want your active participation till the end while the panel discussion is on. All these questions can also be answered then, because since this is a very back-to-back session, we will also try to address. But one question that we can quickly address is, probably we can respond to is, Rajesh, if you can see on your Q&A session, you have a question posted there. So is the process taking place in inert gas atmosphere? Rajesh, that's one of the questions.
So, yeah, so for the Melteo machine, yes, it does take place in the inert gas atmosphere, but it's only within the, around the wire. So we don't need an inert gas atmosphere around. So when we are integrating with a CNC or a robot, the gas is actually flowing just around the wire. So there are small pores around the wire. The wire is in between, and the gas is on the side. So there is a very less gas consumption this case.
Okay, thank you so much, Rajesh. So Rajesh and Monotech they are also our 3D Graphy associate corporate members, and I'm sure as a community we will also be able to address each of these requirements as we progress working together. And respondents can also reach out to us, and also Rajesh in terms of the requirement going forward. Thank you so much, Rajesh, for your presence, and please do be there as we progress to the day. While people will have a lot of their queries, so we can probably address them towards the end, because this is interesting with all the sessions going to be back to back in terms of some learnings. Thank you so much, Rajesh.
Sure,
so now may I invite Mr. Sarup Chand, who is the director with Endotech, who is also one of the companies offering solutions in 3D technology. Mr. Sarup Chand has been in the space for almost last 2 decades. offering solutions in 3D technology. But as a company, they are well set in Delhi, and they have almost 14 to 15 different branches across India, offering solutions in 3D printing across sectors. Also, the portfolio is very similar. What is expected in terms of various materials, polymers, metal.
Yes, please.
Thank you so much, Saurabh. You can start your presentation, please.
Can you see my screen?
Yeah, I can see the screen, but you need to enlarge it so that we can start.
Sure. Okay, good afternoon, and I'm eating into lunchtime, so I think it's a big challenge. But I just would like to share some of the experiences which we have had with a couple of customers in Indian Navy, with other maritime equipment manufacturers, as well as with some of the spare part management or spare part manufacturing. All of us know that the shipbuilding industry is a huge industry, and as in the earlier session it was mentioned that if we can even take 2 to 4%, it can become $2 to $4 billion company. Ship, as all of us know, is a very complex, well packaged. I think the packaging is very critical. It's a very small area. It's a full industrial plant, a colony moving on water with little access from outside, and therefore it has its own challenges. So additive manufacturing has been aiding and has been initiated in terms of use across the globe, and it is being used for different type of application. But the key reason for transformation, as has been highlighted by Mr. Paul, is that it does not require any tooling. There is no minimum order quantity, and the trial of alternatives is very economical and time efficient. The key use is lightweighting and integration of many parts. I think the complex geometry is a big advantage in terms of freedom of design, and therefore it can be used for distributed manufacturing with very high security built in. Traditional methods will be little inefficient, and that's why it is being pegged as a transformative technology. It's today being used for prototyping and functional scale models across the globe. It is being used for spare part in metal, composite, rubber, clay, as well as in ceramic. And I'll share with you some of the examples from India and not from global market. Aging parts can be reverse engineered, where the scanning or the dimension based design can be used for creating the 3D model. And I think the biggest challenge is how do we create the digital inventory of the parts which have to be reverse engineered if the 3D printing has to be utilized. Indirect applications, as again Dr. Paul mentioned, is the mold for the composite layup of any size can be built with the 3D printing, and we have been doing it with couple of companies in India where the mold for composite layup is being done today with 3D printing. The pattern for the casting, and since we can create the prototype which are functional, you can use it for training and visualization, which is equally an important application with a variety of ships and the other maritime equipments which come in. The other very significant thing which we saw in India is the availability of jigs and fixtures. So even to open a particular part, it is very challenging. And therefore, when we started working with some of the projects with defense, we found that the jigs and fixtures which are customized for a specific work are not something which may be available, and the 3D printing can be a big aid to that. All of us know that those don't require great certification as long as they function. So an adoption of 3D printing can actually start from jigs and fixture as a critical application. Of course, it gives light weighting, and improve the energy efficiency. Having said that, what are the materials? Because the biggest challenge, as uh, Dr. Kakuri, I'm not able to spell it correctly, Khandupuri, specified, is the material a critical part of the AM, apart from the technology. We as a company at Adroitech have been working in metal, resins, nylon, thermoplastics, which are high temperature thermoplastic, fiber, carbon fiber, as well as ceramic. Sorry, it went back. So, and we have been working with materials in composite like onyx, which is a mix of carbon fiber with nylon, onyx FR, which is fire retardant material combined with the carbon fiber. Uh, in some of the electronic application, you need the electrostatic discharge. So you do not want the charge to be built up. So we do work with electrostatic discharge material. We work with continuous fiber as a reinforcement, and many places you have impact factor which need to be taken. So we work with Kevlar, and we work where the wear and tear is very high, as well as the high temperature requirement comes. We work with HSHT and the fiberglass. In the area of metal, we do work with stainless steel, copper, Inconel, A2, D2, which are hard material, and H13. Some of the parts were shared, so you could work directly with pure copper and build up the parts which can be used in for functional applications. You could work with plastics and resins, which give you the pliability, durability, and the softness. And some of the integration can be achieved, which is very good. So you could see some of the examples of how the engineering resins can be very useful. Our specialization has also been in carbon composite, and we have been working on carbon composite for last 4 years. And today we have generated parts for drones, we have generated parts for Navy, we have generated parts for different defense applications as well as industrial applications, because the fiber itself gives you the strength which is far higher than aluminium strength. So with continuous fiber being added, you are able to get the flexural strength which is very high, and the strength in the direction in which the fiber is laid of almost in GB and not in MPs. We also work in ceramic with materials which gives us the dielectric material property, and also help in the telecom area to make the part, because they are EMI, they don't get affected by the EMI and they cannot be traced very easily. So testing intricate structures in ceramic is something which we have taken the lead, and we are, I think, the only people who are manufacturing the ceramic parts in India. So this gives us the capability of high temperature environment, as well as gives us the capability of wear and tear being very low. So it could be in alumina, zirconium, it could be zirconium black, and very complex parts can be generated with this. Now, I initially thought that I will cover up some of the Navy applications which have been done globally, but my previous speaker, especially Daniel, had covered up many of the applications, and then again, there were a lot of discussion from Khandukuri in terms of how the certification has been done and what are the parts which are being used. But and then Mr. Paul also highlighted some of the applications. So there may not be much of a need, but I'm just sharing that some of the fleet support units at HMAS, which is Coonawarra Navy Port, have developed the parts which are very similar to what has been done. This, I think, Dr. Paul very elaborately explained it, so I just picked it up from them, from a report from McKinsey. This is the work which has been done by Dive Technology of in partnership with Kraken Robotics to build a commercial autonomous underwater vehicle for deep subsea cable and infrastructure inspection. So it was not used as a direct ship, but when one need to do the inspection or one need to do the underwater operation, you also still need the equipment which are necessary, and this could be one such example where the large parts could be produced. A yacht application, but I think what impressed me most was the mast, which could be directly 3D printed and mounted and reinforced inside because it was hollow with the thermoset material to give it the strength which it could bear. So, one of the most valuable applications of additive manufacturing in the maritime industry is, I think, on demand production spare parts. That is what we have been doing in terms of this thing. So when we started working with one of the projects of the Indian Navy, which is Shivaji, the critical requirement was rapid prototyping, obsolescence management, data digitization, reverse engineering, and replacement of casted parts. These were some of the key applications, and they wanted to take the 3D printer onto the tank, onto the ship itself. And we started working with them couple of 1.5 year back. And today I'm very happy to say that it succeeded, and they, I think it was mentioned that one of the companies has started working with Indian Navy by taking the 3D printer on the ship. We had done this successfully, and now we are starting that project. So, uh, critical requirement is to do the reverse engineering, which is creating the digitization and then building up the part for taking it forward. This is what you do with a physical part, reverse engineer, create a digital inventory. With that 3D CAD model, you can do the printing. Some of the parts, if you can see the original part and the 3D printed part, they function the way the original part was working, whether it was a gear or it was a different type of shafts and things like that. They got assembled, and they also had the accuracy of within the tolerance limits which was worked upon. This is not our work. This is some of the parts and complexity which can be addressed with the help of 3D printing. But another very interesting example are the small parts, not just the big part like boat hull using the composite, which we can do it today very easily, whether it is a carbon composite or it is a fiberglass composite. But equally important are the small parts which need to be made in elastic material, which need to be made in rubber-like material, which need to be put as a holding mechanism, which is required for creating the brackets of different type. Another example is the pipe braces for the brackets and the pipes which need to be created. So I'm just sharing with you that how quickly these braces could be made which would hold. So typically in pipe leakage, the braces play a critical role, and they can be 3D printed, and then they can be used for maintenance of the leak pipes. Another example of small, I mean, it's a officer which is showing it. So I just thought that it may be very useful. They used the Mark IV printer for printing the bumper for an F-35B Lightning II landing gear door aboard the multipurpose amphibious assault ship of USS. Okay. Another example which was used in Australia by one of the customers was in sensing payloads and the equipment which are necessary for putting these sensors in the system. Now, this is not a part which is functioning by itself, but it is a part which is required for creating the whole of the different type of sensors which may be fitted, and they need to be utilized. This was a example which we had done ourselves. which is developed the flexible coupling with different designs and different materials, including the carbon fiber for high torque applications. And uh, here we use the carbon fiber, and you can see it could withstand a torque value of 750 nanometers. Now, we did try different designs, and finally we were able to succeed, because originally, even with carbon fiber, it was cracking, but then we reoriented the carbon fiber to be able to give this type of a design. Another very critical application are the battery casing. So design and develop the battery box for space application using the PSU polymer and carbon fiber mixed with PEEK.
Ramanji, you are mute actually. Yeah.
Temperature as well as very low temperature below minus 20. Another application which we did was a bellow, and using the bellow, it was a perfect bellow using different shore resins. So we used 50A as well as 80A shore resin, and thereby you could function with a very high pressure up to about 3 bar. So I'm just, as a company, graphene powder, of making the panels, of making the filament guide roller for the extruders and applications like this. So in brief, I would only say the 3D printing is not just getting developed by the technology providers, but by the software developers, simulation people, material suppliers, service providers, and various consultants. It is growing rapidly, and some of the companies which have been working are people like GE, DMG Mori, BASF, Henkel, Arkema, DuPont, companies in software development like PTC, ANSYS, or service providers across the globe, and that is what leading to the growth. So I just sharing quick example of how we started doing the work. So we first put the 3D printer in the middle, where the vibrations are minimal, and then we put it on the corner, and then we tested it. It went on working up to the L3 level. After that, they stopped the trial, and it was worked at 6, 12, 15, and 25 degree on the top deck as well as inside the ship. And these are some of the parts from scanning to the 3D printing we were able to produce for another naval organization. The other thing which has been done by Markforged, which is very great, is that they have made it industrial field edition. So you can actually carry it and you can work even on a truck and there would be no problem. So it has a large build volume and it is fully on the mill specifications. You can support the 3D printer and can work in the field with no major problem. So it has different type of foaming structure, aluminum honeycomb, lightweight support layer, and things like that, which gives it the capability of being able to carry around on a truck and then work with it. So, in brief, this is what I had to share in terms of material and technology. All of you know about these technologies, so I don't want to touch upon them. The, there are SLA printers, FDM printers, which are very accurate, um, which gives us the capability of printing it in any of the resins, which give us the high temp flame resistant material, which gives us the pliable elastic material. And of course, you have heard about the metal technology at length. So instead of me highlighting about them, I think the other technology which we are using is the MJF technology, which is a multi-jet fusion technology, which enables us to produce the plastic parts in nylon in very, very large volume every day. So we created in the last 1 year more than 2 million parts for the drone industry, for the aerospace industry, for the uh, uh, automotive industry, today, and medical health industry. So during the pandemic alone, for the various equipment which had to be made, we printed using this type of a printing technology over a lakh part in about 20 days time. The next technology which was not touched upon is the composite technology. Within the composite, not only can you produce the part in composite, but you can further reinforce it with the continuous fiber. And Markforged and some other technologies provide that continuous reinforcement in the direction, and instead of going through the layer process, one can actually, within the 3D printing process itself, can realign the fiber in different directions and be able to get the strength in the XY direction, which is isotropic. Z direction would be slightly less, but there are different techniques of creating the inserts by which you could produce it for different applications. So using the Markforged, you can produce the metal parts, you can print the uh, SLA parts. This I have already touched upon. I think I am going. So we today as a company have HP MGF, we have Formlab, we have a Delta Wasp which prints in plastic and clay. We print in metal. We also print in ceramic and silicone and rubber. So that's an experience which we have gained over a period of time. We also have a team which does the design for optimization, design for additive manufacturing in terms of reducing the weight and improving the capability of integrating the parts so that the reliability of the parts can be done. Now, you have heard of applications in maritime which are on the ship. We also work in terms of a 3D printing of a terrain model, which in the sea is a reverse model. So you could also create a shoreline as well as the sonar wave reverse engineered into the terrain model of the sea. This machine, we don't have it, but we have a representation where we can print the dielectric as well as the electrical conduction together to give you the capability of printing the electronics, which includes even the antenna. And here you can even go up to 32 layers of the PCB with interconnected cables. You can use it for different type of applications. So we have used it for drones, some of the parts which have been done, including the camera fitting, which may also be very critical in your day-to-day applications. It could be for creating the structures, could be creating the hollow blades which can be used, and different type of components which can be a replacement of the metal parts, or maybe actually used as a uh, replacement of injection molded parts. So having shared with you, these are some of the examples. So complex tubing, which would have been in multiple parts, could be directly manufactured in 3D printing and could be used. So companies like Shell are using it, the 3D printed tubes now wherever the 3D pipes have to be done, which means the pipes are curving in any desired direction, which would be the requirement in any ship or a complex area or a small area where the aluminum, where the tin sheets cannot be bent or the pipes are not available to be bent. This can bear 6 bar of pressure and can work in giving you the smooth flow. It could be aerofoils, it could be the manifolds of this thing. So these are some of the ceramic parts which I just thought maybe sharing, which can help you in even taking the wires or routing very quickly, or the antennas which can be done. Thank you very much. I thought I shared with you a couple of applications, couple of technologies, and as a company, we are a solution provider, which means we provide you the full equipment and enable you to do the production yourself. And we are also the service provider. So, provider, even if you're not buying the equipment, we can provide you the services of developing the part. And once your needs get identified and your needs get matured enough and you have proven yourself, you could acquire the solution from us. Thank you very much.
Thank you, Dr. Sarup. A small, quick comment and a question. You were mentioning about the graphene technology. Could you elaborate what all has been done till now in that?
Sorry?
You mentioned about graphene technology.
Yes, sir.
So, what are the items you have created from the graphene?
Sir, it is at an experimental and project level. So some of the professors wanted to work on graphene. So we actually created the graphene powder. And with that graphene, we were able to give it to them some of the parts which they are now testing it up and doing the classification.
I would like to have one-on-one discussion with you on some specific requirements for military use. So, I'll take your contacts from Dr. Shibu John and get back to
Yes,
you.
sir.
Thank you,
Sure.
sir.
Yeah, thank you so much, Saurabhji. And over to the next speaker, we want to introduce Raman Kumar, but we had to introduce Raman Kumar, but unfortunately he was not keeping well. So we have in place of him is Ashwin Deshpande, who is heading the additive manufacturing and business development for Intech Additive Solutions. Ashwin also comes with a good background of CAD and design for almost last 2 decades, and he is responsible for scaling up the business for additive for Intech Additive Solutions in the country. Also, an indigenous manufacturing 3D printer metal company has come a long way for the kind of efforts. I know the owner, Mr. Sridhar, personally. I mean, they've been doing some great work. They initially started offering services, but now they have indigenously manufactured one of the state-of-art metal 3D printer in the country. So, welcome on board, Ashwin, and you can take your presentation through. What all
Thank you. Thanks, Shibu, for the introduction. And unfortunately, our Mr. Ram Kumar, who is the director of consulting and application engineering at Intech, with a very, very vast hands-on experience in metal 3D printing. In fact, probably one amongst the first end users of metal 3D printers in the country, where he implemented this machine for conformal cooling dies in his previous roles and assignment. So, wishing him quick recovery. I will share some of the things about Intech, and the audience can ask some questions over there. I'm going to share my screen. Thanks again. So I'm Ashwin. I am responsible for the business development and sales for Intech in India. The agenda is short and simple. Previous speakers have talked a lot of challenges associated. So I'm going to cover about the Intech as an introduction and some challenges which probably will be repetitive, and 3D printing as a viable alternative. And again, some of the advantages have been spoken at length in the previous by the previous speakers, and dwell little more on the Intech expertise and some case studies. These are our own case studies. Yeah, so as Shivu said, he knows our founder and owner, Mr. Sridhar Balram. He started Intech DMLS, the earlier name, as the India's first metal 3D printing service bureau, which was recognized by Woolers, one of the leading publications that tracks the additive manufacturing industry. That's him. And we, the kind of work that we did attracted the interest of DMG Mori, and they invested in our company. So they are an investment partner in Intech. That's the DMG Mori team. We offer end-to-end solutions in the aerospace, automotive, general engineering, tooling, medical, and dental industries. We also, so we have many firsts in MRM. As I said, we were the first metal 3D printing service bureau in the country. We also became the first OEM in India to design, develop, manufacture our homegrown indigenous class 1 metal 3D printers. And not only that, we are also amongst the many few OEMs, I would say, who develop their own softwares to run their machines. unlike other reputed players, they fall back on some third-party software. So our vision was we offer a complete solution without any external support to the Indian industry as well as the global industry. So we develop our own softwares to drive the printers. We also develop our own softwares for, we have a software for new material development, parameter optimization for, yeah. That's been our journey. We started 2012 as the first Indian service bureau in metal 3D printing. We launched our, over the couple of years, within couple of years, we realized that making the customers adopt to 3D printing or use 3D printed parts, we need to develop expertise on design for additive manufacturing, and we created a team which is growing in big numbers today, and we invested in the leading the structural CFD solutions, that's what we started in 2014. Again, we launched the first parameter optimization software in the world, first of its kind in the world, somewhere in 2018. That's when the DMG Mori partnership also happened. We also launched our own AM process software, that is for the data preparation. Along with that, we launched our India's first indigenously built, designed, built, developed a small format laser powder bed fusion machine. And then 2021, we also launched our large form machine, and we got several installations today done in the domestic market, and we have one international customer. Very proud about this growth that Intech has had in this past calendar year. 2020 unfortunately was all pandemic, and we use that time to do more R&D on our machines, do more testing, and the result of which we have over 9 customers today, 8 of them in India and one in Europe. So maybe repetitive, but just to summarize, current methods of repair replacement of parts on ships are through the conventional manufacturing process like casting, machining, and investment in tooling for low volume needs. Typically, these requirements of MRO parts or repair parts are low volume. The cost per part increases, the lead times are longer. The supply chain, as we saw, in the initial session, where some parts are manufactured in Brazil and then shipped across to maybe India or Europe somewhere, and many times the delivered parts come late at the port, wrong parts come, parts go missing in the transit. So many issues the shipping companies have to face. Of course, they maintain physical inventory. That means they're locking their capital, the precious capital, and any idle time of the ship at the harbor is revenue loss for the shipping company. So some of the high level challenges. And then legacy parts, availability of legacy parts. We heard Mr. Daniel talk about that. Spares are not available, or has long lead time, or sometimes it is very expensive because the supplier is the only company. So some monopoly situation. So what 3D printing can or how 3D printing can be a viable alternative. The MRO parts, like we have seen several parts in the in these presentations. So the replacement parts, this can be manufactured through 3D printing, tools and accessories and fixtures. So re-engineering of parts in digital formats, or reverse engineering, re-engineering, maintain digital inventory. The 3D printers can be ashore, that is at ports, or they can be on board the ships. They can be on the ships. Parts are rather come in days rather than weeks or months. Close to original mechanical properties can be achieved through the metal 3D printing technologies. Of course, lesser for carbon footprint, reason being the supply chain is shortest supply chain. I think 3D printing is the only technology which has got this shortest supply chain from getting the parts delivered or manufactured just in time. Of course, fewer resources are required, unlike the conventional manufacturing where we have several people working on several work stages to complete a part. So a brief on what is 3D printing. Again, a very, very, very brief thing. So the fastest path from CAD to part is 3D printing. No investment in tooling, little or no penalty on design change, near net shape manufacturing, and a variety of materials now. Yeah, so this is where this is typically how the process would start. You have to look at the parts. If materials are known or unknown, do reverse engineering, check their viability or feasibility, economic as well as technical, for 3D printing. Maybe use design for additive manufacturing principles to modify those designs to make them best suitable for 3D printing. Once that is done, if some simulation analysis, whether CAD or structural, can be done. Important that, okay, while we say the variety of materials are available, there's still a certain amount of library of materials which are available, though it is getting enhanced almost every month, I would say. So, and then the build preparation, then you print them part, you finish them, post process them depending on the requirement, any heat treatment if required again, and then do your quality assurance. So typically this is the will be the workflow. This video, I hope you can see this, just about our small format machine, more about the process. So iFusion is the name of our brand. This particular machine, small format machine, has a cylindrical build envelope with height of 180 mm and a diameter of 150 mm. We chose this particular configuration with all the study or the experience that we had in delivering services, metal printing services, for several years. This is a sweet spot, best in its class in terms of the size and the value that at which customers can acquire this technology. So AM Builder is our pre-processing software, again homegrown, indigenously developed, and then the parameter optimization. So a variety of materials, and this library is going up every month. This is how we are, I would say, as a company, we are structured. We have the design consulting services, which we launched in 2014, the DFM services, where we can walk into a customer place, identify their parts, suggest modifications, do reverse engineering, and at the end of the day, deliver a full solution to the customer. We have our own softwares, that is AM Optomed and AM Builder. The hardwares, we have today in the market, we have 2 machines. There are few more in the development stage, which will be launched in the next few months. And then on demand parts, our original business that we started with. We cater across most of the industry segments. I don't think anything is left out. And we are seeing a lot of traction in the lifestyle, and you will see and hear some news about InTech in the lifestyle very soon. These are our machines. This is our small format machine. This is a large format machine, more tuned for production applications. This is more tuned for new material research development, for small size parts. AM Optomate is the first of its software in the world where it helps a user to create parameters, to create optimized parameters for existing materials, and this is machine agnostic. Any other brand made machine user can use this software to develop parameters, optimized parameters for different materials that they use today. This software is also can be used in developing parameters for new alloys. I'll show you one case study, particularly over here, an Indian case study. And this software actually does the work, if the conventional way, what the customers have to do when they have to do new material development or new parameter optimization, it takes several weeks, or it can go into months. So anywhere between 3 months to 6 months was the timeline to develop new materials or optimize parameters. This does the job in about 10 days, less than 10 days. And the AM Builder, which is a data preparation software. Just a brief about the large format machine. That's the size of a part that can be done, and it can be configured with single, dual, or quad laser. This machine is just with a single laser, but again gives a 500 watt laser power. Again, best in its class. Some of the materials today that are available on our technology or our machines is what you are seeing, pretty common materials. But here, what you see on the slide, point number 8, super alloy CM247 LC, specially developed for HAL, Hindustan Aeronautics Limited, in Bangalore, for one of the aero engine, and there was a press release for that. And then this material is a special alloy again of steel. This was developed with Indian Institute of Science, Bangalore, and for these two development, our AM Optomat, the optimization, parameter optimization software, new alloy development, parameter development software was used, and in matter of couple of weeks, these materials parameters were developed. Some case studies we'll see. Again, this comes from the oil and gas segment. Partially can be considered as the maritime industry. Again, in this case, spares were not available. That's what the challenges, and the machining cost and lead times were high. And the old design with the straight lines that takes the fluid from one end input to the output or the outlet, the efficiency was low, and that's where the DFM, design for additive manufacturing team, came into picture, and we understood the boundary conditions under which this part is performing today. Taking those boundary conditions, we redesigned the part with software that work on the principle of topology optimization, of course CFD, and we did structural analysis, and at the end we achieved a 75% weight reduction with a improved flow efficiency over 55%. So we believe, so what you see over here, this is the original that part to be replaced. This is the AM design, and this is the actual 3D printed hydraulic valve. So what we believe that DFM, if DFM is practiced well, and if we can handhold our customers in DFM, the adoption and acceptance of 3D printing will be much faster. That's where the even the economics and the overall benefits be worked out as compared to just taking a part and 3D printing it as it is. So this was the case study that I was talking about. You see our large format machine here in the background. These are the team from HAL, from the aero engine department. This was the alloy in which the parameters for this alloy were developed, that is CM247LC, and this is the engine component. The size of the component is approximately 320 by 70, and the point to be noted here is generate parameters virtually. Conventionally, it would have taken anywhere between 3 to 6 months, as I said. Typically, any new alloy development is a matter of huge investment in time and cost. But AM Optomat, with all the algorithms that we have developed, all the data analytics that has been put into it, again, backing over our experience, we got this part done in a couple of weeks. And the uniqueness of this material is it is crack prone, and previous attempts by the LTVF technology company has not been successful in actually producing the functional part with this material. So for the maritime industry, I'm sure there are materials which are standard, and there will be non-standard exotic materials, and we as a company, Intech, can offer, we can bring a solution to the maritime industry in India and of course across the world to develop new materials, specific materials for marine applications, whether they are corrosion resistant or fire retardant, and I'm talking about metal. And so we have the technology, we have the solutions to deliver it faster. One more case study that we have, this is about the engine oil cooler. Again, a DFM case study. What you see over here is the conventional old design. Engine oil cooler acts as a two-way heat exchanger. It's a heat exchanger basically. So what you see over here is the design for metal machine, metal additive manufacturing, the heat exchanger. So some of the results were the oil is made to pass over the fins with higher surface area. So if you see the fins over here, so this all primarily came as an ideas from the DFM methods of design that we did. Cost reduced by almost half, reduction in pressure drop, and weight reduction by over 25%. So we feel that these are some of the applications in the marine industry that are possible, can be done, and we have expertise on that. So just to summarize some of our expertise again, we have structural analysis, CAD modeling, reverse engineering, flow analysis, use of topology, optimization or generative design, lattice structures, with all the tools and the team in place. Material characterization, powder development. So we have a technology development department which gets into new material development and powder qualification. We our softwares, our hardwares, we have in-house post-processing capabilities from surface treatment to machining, quality certification, and then we also get into low volume production, and that is on very special note, we don't take any inquiry which is just about 3D printing a component. So if there is some special, the customer is facing a design challenge or a material challenge, ideally we would like to get into that, to offer higher end services. Yeah, these are some of the logos that we have acquired in the calendar year 2021. A couple of more are there, that will be announced as we go forward. So we have a machine there in DMG. So DMG Mori also has our machine. At the same time, they are an investment partner in Germany. They have a machine. Conify is a customer in Greece. They again not only liked our machine, but also we found our AM Optomat, the material parameter development software, very, very useful. And some Indian customers, Indomem, a leading metal injection molding company, and some leading institutes like IIT Madras and so forth. PDU, this is in Pandit Deen Dayal Energy University in Gandhinagar, Gujarat. So yeah, that was that's my presentation.
I should really commend Intech additive solutions on a platform like these, because now this is streamed and it's going to a connected audience of shipbuilding companies and also ports. So I've already got some fantastic response from key respondents, from various sectors. Also, what we are proud of is, Ashwin, that an indigenous manufacturing company, from where it started as a service provider to stage a metal company in the country, is not a joke. We know, I've been in the space for last
I
8 years.
I agree. I come from I'm a professional.
Yeah. So
I'm a professional. I have huge respect for Mr. Sridhar Balram
yes,
for the courageous step that he has taken. It is a brave step.
It's a brave step, and I really appreciate the effort. And platforms like these, we should also promote indigenous companies, and we are very proud of that. So, including you, there is also one company by the name MS. They're also doing their bit in terms of promoting it. So, I think it's. I mean, that's how the technology will get its core attention in a country which we're still not aware of additive manufacturing too much, and for an extent that I know. Which was very late lately that I could connect with Wing Commander Raman Sopuriji, who is a active respondent with us, for us to have formulated this committee for additive manufacturing. I know many of them would have done in the past in terms of forming an association, but nothing. That what I found is, now that we are seeing that there is a momentum. Ramanji, if you have to just pinpoint on some points here of establishing a set structure in terms of, for us to see and promote indigenous companies in the country, should be our prime objective also, obviously, but that doesn't mean that the other. But I think the larger intent is very clear, and we will want to always promote indigenous company first, because I see a message in the box. But yeah, we should promote companies and be very responsible. That's our first primary objective, including anybody who is looking at new developments, working in Confluence, in also for transfer of knowledge and implementations. That's how the technology will get its scope and space in the country. Sir, your comments on this, please.
Sir, thank you so much, and it was an excellent presentation. I never knew such a good work is happening in India. I just want a specific question on what you have been doing with IIT Madras. Then my second question will follow.
Okay. With IIT Madras, one of the main association or the collaboration is happening on material development, new material development, new alloy development.
Okay. Now, in terms of the the expansion of the industry, suppose all of us invest money into the industry, do you think India has got enough talent pool to meet the requirements of this industry, or you need some kind of a human resource policy of the industry? What is the kind of talent you have in the market in case investment, as you talk of, come in? So will there be a shortage? What are your suggestions for that? Getting
Yeah,
the right talent pool in India.
yeah. One of the things that the Indian education system.
Hello, your bandwidth is gone. Is he back on the line? No.
Yeah, he's back on the
Hello.
line.
Yes, sir. Please, you were off the
Yeah,
line.
I don't know. Something happened. Can you hear me?
Yes, loud and clear.
Yeah, your
Yeah,
screen
about
is
that.
very close.
No,
Need to
I
slightly
have
up.
gone on my. I have come on my mobile. I don't know. Something has happened with my system. Yeah,
Doesn't
something has
matter. We
happened with
can
my
hear you.
laptop.
Please go ahead.
Yeah,
Yeah, we
yeah.
can
So
hear you.
the question was the Ministry of Human Resource, or the Education Department for that matter, has to. I mean, they have done. I mean, for the last few years or more than that, we see additive manufacturing as a part of post graduation course. But still, it has to become more, mainstream in the mechanical engineering or the production engineering course, where the design for additive manufacturing as a course where should get taught to these students, and that's where the manpower will be generated, because operator level skills are pretty minimal. I mean, if I can operate a CNC machine, I can operate a 3D printer. I mean, any
Okay.
3D printer. Doesn't mean it has any polymer, ceramic, or composite, or metal. Yeah. So operator skill sets are minimal, and that's where the automation has gone so much into the technologies. Not only our machines, but several other machines there in the field, in the market. I believe it is the design that has design thinking, which goes into creating a part and unlearning the previous principles of design for conventional manufacturing. So whether it is casting, molding, machining, extrusion, and so forth. So yes, I think our education department has to look into the design for additive manufacturing as one of the coursewares or as a subject that has to be, and they should not probably get related to, or rather get locked to only a PG course. I'm of the opinion it should come in the uh, undergraduate course as well.
Yes. Thank you so much. And we'll get back to you. We are forming a committee on this by recommending to the government. So, do you know who are the people training? Suppose you advertise for a job in your
Hmm.
company. How do
Hmm.
you hire the people for 3D printing in your company? What is the
Yeah,
way?
so we have been hiring young graduates. So we have today intake is about 100 people in the organization, and only maybe 10% of that are experienced, like 20 plus years or to 30 years of experienced people. Yeah,
Yeah.
but rest of the team is all young engineers from various, typically from the southern state, because we are headquartered and we are only present in Bangalore. So most of the students have joined us from various institutes from South India, and they're basically judged for their design skills and mechanical engineering and production engineering, principles. And then we end up teaching them all that is required to become a good additive manufacturing professional. So we are hiring. We hire a lot of people, and we also take interns. We just got an intern from one of the customers, that is Pandit Dindiyal Energy University. He had some background on 3D printing in his courseware, and well, he passed the requirements.
Thank you so much. And how many employees you have?
As I said, we are a team of around 100.
And
Everybody put together. Yeah.
and how many ladies in the team of 100? Any 3D?
Yeah, we have lots of, I would say lots of, we have more than a few ladies or women in our design for additive manufacturing team. Yeah.
Okay, thank you very much. We are looking
Yeah.
for some kind of award ceremony to congratulate the best lady worker at the shop
Oh,
floor
okay.
in 3D printing. I am looking for some talents also. And if you can help us guide who is the best person in southern
Oh, if
states.
there is if there is some entry, then we will participate, and we can,
Yes,
our
we will get back to you
our
on that.
female
We'll do
colleague
an email.
can be nominated. Yeah.
Yes, we'll do that. Yeah. Thank you so much. Over
Thank
to
you
you.
very much. Thank you, Shibu, for this platform. and appreciate your efforts to make 3D printing more mainstream in India and establish a good, healthy ecosystem.
Thank you so much, Ashwin, and congratulations for the new start. And I'm sure there's a long way to go for the company going forward.
Sure. Thank you.
So now let me also take the opportunity to invite another key respondent and a good friend, Dr. Vishwas Putting. Dr. Vishwas is his expertise in validation and certification in his past stint, and also been very active in terms of ISO certification and also a Six Sigma in terms of manufacturing and processes in manufacturing with ACE Microtech. Very proud also to have one more indigenous manufacturing company in 3D printing in the country, and additive manufacturing in metal. Why I'm stressing on metal is because everybody has been talking about metal being a very it's a challenging affair because you need research to do and get to that stage to offer solutions. While FDMs are desktop machines with polymer, but there are also other machines offering solutions in various different polymer space. But I'm saying metal has always been a challenging space to get in. And also with their expertise of almost last 6 decades in CNC machining, this also happens to be one more addition in the feather in terms of the efforts being made. So always a pleasure to connect with you and also have you a key respondent, Dr. Vishwas. Dr. Vishwas is heading the business for Amaze Solutions Private Limited, also one of the sister concerns of the organization, Doctor, if I'm right in terms of expressing it. Yeah. And also very lately they've also manufactured this machine and up and running. Also got their units booked for, I think, in China. That's another great achievement in terms of also having your presence in China for almost last 3 decades that you mentioned the other day. Thank you so much, Dr. Vishwas. I may now ask you to please take us through the presentation in terms of what you are in the offering. Thank you so much.
Great. First of all, thank you very much for this opportunity. Am I audible?
You are audible. Thank you so much, Dr. Yeah.
Great. I'm assuming my screen is visible?
It is, yeah.
Great. So just to start here, first of all, my hearty congratulations to the 3D Graphy team here who've put together an excellent event here. And I also see series of such events with this one dedicated to maritime and shipping. And it's a great opportunity for Amaze to be making this presentation and sharing a bit of our own perspective and learnings from 3D printing in this industry. So just to continue the point that you made, Dr. Shibu, Amaze Solutions is a part of ACE Micromatic Group. And as a group, we have been in the country for 40 plus years. More so, you can say we are kind of the backbone of the manufacturing here, where industries across the segment, across the country, from automotive to aerospace, defense, outer space, and the mold making industry, education sector, in every possible stream, we've had our presence. We've sold our machines with a presence of over 60,000 plus CNC machines made and sold in the country and also outside. We've been there in manufacturing for 4 plus decades. And this is a group which is 100% indigenous, made and started by engineers, technocrats who came out of design school and decided to get into designing and building of machines, and progressively have added multiple of the product segments in the past years. So in each of the verticals that they have started, be it CNC turning machines, be it CNC milling machines, grinding machines, or IoT solutions, we've been one of the most value adding in the country and the most preferred supplier for the Indian manufacturing. And with this, I'd like to start. So our journey started way back in 2015 when we decided to look at what else beyond the conventional machining or the metal cutting space what more can we offer to our customers. We wanted to diversify from a CNC milling or the cutting business to something more. So from that perspective, we decided to get into the additive manufacturing as a segment. So this is what led to us entering into the additive from the conventional subtractive way also. So that we are able to handhold and partner with our customers in all their new initiatives from technology perspective. So today's quick short presentation, we've focused it around these 5 topics. We'll start with our perspective as to why additive, and then we'll look at a few different, I will end it short so we can have a good interactive session for discussion. So coming to additive, I think we've had an excellent start from the morning, so I'll not repeat the common ones, but from our perspective, what we believe additive is very complementing to the subtractive manufacturing, and we say additive is very close to nature. The natural way of manufacturing or creating anything today is the additive way, be it a human body, an animal, a tree, a plant. Every aspect of it is made the additive way. And what it also offers is simplifies design, and it offers assemblies to be made. So which we all know, we've seen that where complexity increases, additive manufacturing becomes more and more a preferred choice. A lot of lightweighting today, we are seeing this extensively. We are working with some of the very new segments like electric vehicles, aviation, outer space. A lot of space manufacturers have shown interest. So we've been doing work for such people where weight becomes extremely critical, and every gram, every kilogram becomes more and more important. So we've been working in such situations also. And what we also tell is freedom to design. Anything that can be perceived can be actually produced in a very short period of time. And of course, variety is free, which means we've printed parts where people have had different varieties of parts, all moderations or iterations of designs all printed together. So this becomes very common. I mean, wherein variety can be done free. And it's a near net shape, green manufacturing, where you have very less wastage. So these we feel are some of the prominent advantages, which I'm sure is known, but just reiterating that from our perspective. Now, as we know, it's a layered manufacturing process compared to conventional process. There's a lot of wastage in which to bring the part from a solid block or a raw material to bring it, to give it to shape, we see a lot of wastage. Whereas with 3D printing, you get almost negligible wastage, and the final part is ready very quickly, which is what we've seen. But there's an interesting perspective which brings out the choice as to where additive comes into picture. So when you see here, when you plot complexity versus cost, conventional manufacturing grows exponentially with increasing complexity, whereas with 3D printing, its complexity doesn't matter. All that matters is the material and the time required to print, irrespective of the complex shape. 3D printing becomes offers the same kind of costing. So what you see here is beyond a tipping point, 3D printing becomes much more viable and makes much more economic sense with increasing complexity. So this basically enables manufacturers to consider, especially when there are complex parts. So that's our perspective as to why additive and why people have started looking at it. From a technology perspective, I think this was already explained. Plenty of technologies. This also is probably outdated now, because with so many other newer technologies that are coming, probably one of the fastest growing technologies today in additive is, are these here. And from what you can see, interestingly, the graph shows you, or the image shows you here from different perspectives, what technology would be more suitable. So there are newer materials, the ceramics. We've had different types of complex materials that are being researched on. Combinations of materials are being researched on, and newer techniques which could combine them together and which could print them together are being explored and being offered by manufacturers today. But as it was explained earlier, polymers and metals are the most sought after, especially when it comes to industrial applications and applications like maritime. So from a material perspective, we've seen sand, polymer, ceramics, graphite, of course, different varieties of metal alloys, and of course, even diamond. From a cutting perspective, today people have 3D printed materials like these, which are gaining importance from an industry perspective. Now, moving to the industry that we have focused on today, our core area that we've researched and we've been working on for the past many years is the powder bed fusion, especially the laser one. Our commercially available technology right now is just the laser one, while we are working on many other technologies. Right now, this is what is ready and has been, where a lot of work has gone into manufacturing parts and offering it to customers and getting them all validated. So the technology is straightforward, as we all know, multiple layers of powder being spread on a platform which is melted, and the power source being a laser beam here, and can go from anywhere from 20-30 microns all the way up to 100-120 microns. And this is an iterative process of printing layer by layer, and powder is the raw material that is used in this technology. So this is what we have been focusing on. Different metals, metal alloys that we've been working on that are more popular in the industry today, stainless steels, different grades of them, which are available and which are also well received by maritime and shipbuilding industry, where we've done some work. The stainless steels, precipitation hardness steels, especially from a corrosion resistance perspective. Then we have your Inconel alloys, high nickel based Inconel alloys, maraging steels, especially from a dye and high hardness perspective. People prefer this kind of material, and we've had some work done there. We've had other exotic materials like titanium, aluminum, and different grades of other steels or cobalt chrome alloys are also popular, gaining popularity today. So there's just a summary of the kind of materials that are being printed today from a metal perspective. Now, coming to the main topic of today, from a maritime perspective, we've had interactions with multiple agencies and departments, both in India and outside, who have shown a lot of interest and who've done some work in the maritime and ship building. But from a significance perspective, what we've believed is there's a huge impact on economy. What you can see, about 90% of the goods that are transported today are done by sea. And from a number perspective, there are more than 24,000 containers that are shipping at any point in time, which is the largest size that is done. And from a value perspective, today we're looking at about $14 billion worth of goods at any point in time is in water, is sailing, which is a huge value today. So it is of immense importance to us as an industry for material movement. And the small issue that happened at the Suez Canal caused huge disruption. And what you can see there is, in terms of $9.6 billion a day was the kind of damage that was seen. And over close to 370 ships were waiting to be passed during that 6-7 days of a halt that happened. So this can be it could have a huge impact on the whole economies of countries. So it calls for a lot of importance, and how 3D printing can fit in is what we've tried to identify from multiple areas in terms of development and producing parts for the maritime industry. Of course, there are constraints today which are largely size related. Maritime is not something which calls for high volumes of production in a very short period of time. But from a 3D printing, especially from a metal perspective, the sizes of the components that are required to be produced are extremely large, and the metal printing industry is yet to graduate to that kind of sizes. But we do see, from what it used to be to what it is today, there's already good work that's going on in increasing the sizes and making it more and more suitable for large-sized components to be accommodated. Having said that, there are technologies which are accommodating 3D printing from MRO, repair, overhaul, maintenance, kind of applications. But what is surely catching up is this subject wherein digital inventories, what we mean by that is on-demand manufacturing. We've had people, conventionally what happens is when there's a requirement for a spare part or any item for either production or as a spare part, it goes through the conventional way wherein you have a very long lead time. If items are available, then people go through the conventional process of manufacturing it, which could be extremely long. Whereas with 3D printing, people today are maintaining digital inventory, which was non-existent earlier. They're all being converted into 3D models, and they're kept in multiple locations. We ourselves have worked with a few such manufacturers where their whole working principle is based on maintaining 3D inventory in cloud space and making it available, retrieval, and making it available for the manufacturers at any point in time. For more than 30 years, they've committed to keep the inventory, and they will make it available for the manufacturers, and they will even produce these parts and offer it to them in a very short period of time. So database can include anything from spare parts, the details, 3D models, your material data, property related data. All this will be made available, and it'll be kept, and retrieval of this will be very quick, and production of that also with 3D printing will become very fast. So this enables much faster activity from a maritime spare parts perspective. Now, so basically, a lot of manufacturers today are considering printing these at the port itself. So a lot of activities that are being planned from an overhaul and maintenance, like I said, MRO perspective, and parts are being produced right at the port where there's a requirement, instead of being done at some remote location. So similar concept, what is being done is the entire manufacturing value chain is being disrupted. So what you can see, the entire idea is kept in a cloud space, and then 3D printing, it's 3D printed, and it's offered to the 3D printing process, and the local manufacturer provides it to the end user. So what otherwise is going to follow a very long route of value chain or supply chain is completely converted by the new method of manufacturing. So this is what is drawing attention and shortening the entire production process, especially from a time perspective. So this is the interesting concept that I explained. A lot of manufacturers, especially in the West, have started creating the entire manufacturing setup at the port, where inside the containers there are machines, post-processing, all of it that have been fitted in. So it can be moved from from one location to another, or they can be more agile, and they can be moved flexibly from one location to another based on the availability or the requirement of the work here. So containerization of the whole facility is what is gaining momentum in the West. And so as I said, at the naval bases is where, especially from a maintenance perspective, from what we know, the inventory of some of the spare parts that are required to be produced have grown into a very large large list. So a very long list which needs to be converted, and in some cases it can run into a few months to be replaced. Whereas with 3D printing, all that can be reduced substantially. So one of the countries which is leading this activity is Singapore, which is a leading hub for maritime, and this has gained immense potential there, or momentum in Singapore. So similar concepts are being replicated in different parts of the world, and India is also showing interest in this particular aspect. So another technology that we are also focusing on is WAM, which is wire arc additive manufacturing, wherein you have equipment, wherein you have predominantly from an MRO perspective, repairs of parts, repairs of large blades and other parts which are there, which are being corrected by wire-based deposition and printing, which is what you can see. Similar typical examples are shown here, and most common materials are your nickel, bronze, Inconels are the more common materials that are there. In this specific case, what is being considered is about 298 layers of the machine, the part that was done. So, especially from a spare parts repair and MRO perspective, this again is becoming more and more popular. The technology, the VAM technology for correcting existing parts and then putting it back instead of discarding the whole spare part. So these are the typical kind of parts that US Navy has done, and this is again done inside a container, what was printed and done inside inside the container. And some of the parts well known are your turbochargers, your nozzles, and other parts which otherwise would take very long are all done in a very short time. One of the another pioneers is Hyundai, who are into all parts of manufacturing and also into maritime. They're one of the largest shipbuilders, and they have a new center for 3D printing, which has been established for spare parts and critical parts today. Another popular name is your Hamburg ship model, where again 70% reduction in production time and 30% reduction in production cost was achieved with 3D printing, where they've taken up additive as a key manufacturing process for a lot of their production parts also. So these are some of the typical examples from a maritime perspective that we wanted to bring up. And of course, from an advantages, specifically here, shorter supply chain, we have material cost reduction, delivery time reduction. A lot of complex parts can be done with much more ease. We saw the on-demand manufacturing part of it. From a preference perspective, what we've seen specifically for the industry accepted parts, we have powder bed fusion, laser-based, and VAM for larger parts. These are the most preferred technologies that, from a metal printing perspective, that are being seen today. And from an end user perspective, we have ship manufacturers, shipbuilders, the logistic companies, and part manufacturers from a spare parts perspective. And of course, the naval vessel guys. They are the ones who are more popular from an end user perspective for this technology. So just a few case studies that what we have worked on, parts like these, like turbochargers, which have been done in stainless steel, which is reduced the entire machining time that is required to give you the end use part, or very minimum finished machining would be required for parts like these. Your blades, your turbocharger blades, which either in Inconel or other exotic materials are printed much faster and made available to reduce the machining time. Here again, the advantage is much faster availability, reduction in machining time, and in many cases, wastage reduction also is a key aspect, because you have expensive materials which have to be scooped out, and then you have a lot of scrap that gets generated, whereas with 3D printing, all that can be reduced and made available. This is a turbine nozzle component which is optimized. You have oil holes which are here, which are curvilinear, which are not possible using the conventional way. This was also made and done, which again is probably a combination of multiple parts or done with a different design. In this case, there was a design for additive manufacturing which was done to produce this part. So from a need perspective, what we believe is there's a very strong need to bring down the overall cost of manufacturing, to indigenize this technology and make it available. And like Dr. Shibu mentioned, our initiative and an intention is to do exactly that, where enable this technology, make it available for the commoner manufacturing. It's generally considered as a technology for the corporates or the large players, but our intention is just like how we were able to do for the CNC machines. Over a period of time, we would like to bring down the overall manufacturing cost and make it available for the medium scale industry, so that they can also have access to this beautiful technology, and they can make parts when the technology evolves and when it matures. So our intention has been to focus on productivity. We've developed machines with high-powered multiple lasers to enhance the productivity of the machine. And what you see on the right is our product called the STLR 400, made in India, made by us, designed and developed completely by us. It makes so the reason why we bring it up is it's a large volume product, which means it can accommodate much larger components compared to what is otherwise available as a product. And from a comparison perspective, there's a significant reduction in the cost of the end part that when it gets produced on our product compared to vis-a-vis an imported machine which is coming from the West today. And from a productivity perspective, we are over 200% better, again, on a comparative scale when the products are made on our machines. And these are completely IoT ready. It has all sorts of smart features and interfaces on it where all the information is available at the fingertip and machine can be monitored and controlled from any remote location. And a lot of intuitive features have been built into this machine. So our intention is to give Indian consumers something much better than what they can expect or what they're seeing from other manufacturers today. So basically, what you can see here is our own version of a software that's been developed. This is a GUI, which is very rich and user-friendly, where all the information that is required is displayed graphically. We make it, as I explained, intuitive with a lot of digital information shown in a pictorial way. So it is better for understanding and also taking the needful action by the user. And another key strength of ours is our widespread service network. We are located in more than 70 cities in the country. Every nook and corner where people do manufacturing, we exist as a service center. We are like the Marutis of India in terms of service support because to service our 60,000 plus CNC machines, we have trained manpower who are right now being groomed and trained for additive machines also. They will be available in very short notice to make sure complete handholding is offered to customers who decide to partner with us and go ahead in their metal manufacturing, metal printing perspective. So this is what we had to share in the limited time. Thank you so much again for the great opportunity. I'll be very happy to take any questions.
Thank you, Dr. Vishwas, for your insightful presentation. I'm sure there is much to that we'll also be expecting as it progresses. So, any intention to also explore the possibility of various other technologies, Dr. Vishwas? Now that aerospace, I think most of these solutions have been offered with aerospace that you can do from these technology, the DMLS technology. I'm sure for smaller consolidation of smaller parts, metal parts, yes, DMLS does have the prospect. But what about the size? How would that? How can we achieve that going forward?
So what we've also been doing for the past 3+ years is we've partnered with various research institutes and academic institutes. We have active projects going on with IIT Bombay, two different projects that are going on with IIT Bombay. We have a project going on with IIT Guwahati, where we are looking at large-scale projects, large-scale manufacturing of parts. So one of them, of course, I did share with you. We basically it's something that will allow multiple technologies to be integrated into a single equipment, and that will include laser cladding or laser deposition. It includes a welding or a VAM process that we've done, and putting that all together in a single platform, which also gives a flexibility to accommodate much larger size platforms or much larger size parts. So we're right now in discussion with a couple of industries who have shown interest in that product or in that technology, which will accommodate much larger sized parts, much larger sized end part to be worked on, either from a correction after a wear out or also to build from the scratch the part. And this will come with a milling option also, wherein people are able to do hybrid. They're able to print as well as mill out the parts to give the finished part. So this is something that we've been working on. We also have an active project going on, as I explained, with another institute. Most of these, we are trying to explore the government funding routes, where government has been supportive in some of the schemes where DHI comes up with excellent opportunities for industry and academicians to collaborate and develop technologies. So we've been fortunate to avail some of these benefits in our newer technology development. So the technology that I shared right now is something that is completely established and proven, and has undergone multiple steps of validation, including customer validation. whereas the ones that I'm talking to you are the ones which will come out into the market in the next year or two, which will be made available. So this is from a development perspective. Our intention is not to make one or two products and just sit idle on it. Our intention is to get into aspects that be a overall partner to Indian manufacturers in every perspective of additive that is possible. So this is what we've been focusing on.
And this is across multiple materials in terms of a choice.
Absolutely.
Right. Because then it can be like a pick and choose for companies depending on the kind of requirements going forward.
Sure.
Thank you so much. Thank you so much, Dr. Vishwas, for your inputs.
Thank you.
May I also invite Wing Commander Ramanji also, if he has something to share on this subject and his presentation, Dr. Vishwas' presentation.
Separately, I have a lot of questions in the panel discussions.
Yeah. So I think we will have it. So good. I think Dr. Vishwas, you will also be a part of the panel discussion, and I'm sure a lot of inputs will come through, and I think that will also hold good for us to, take this as a recommendation going forward. I just got a message from DG Shipping also saying that there are some of the chief surveys also they're already a part of the session, and there is a link been served for them to also, who are actually right now also going through the presentation and the details. But I think post the recommendation that will come from our discussion will be a very structured one to share with him and the team. Thank you so much, Dr. Vishwas, for your reports. And may I now invite...
Thank you.
Thank you so much. And now we've been speaking about 3D printing from the morning, but there are other technology solutions also in the offering when it comes to reverse engineering, in terms of having these, while if design and the design can be abated, if reverse engineering can be looked at as an option, I think 3D scanners are of immense value and importance. So now we have Vijay, who will actually share a presentation on the topic on the 3D scanners and how it is actually benefiting the shipping and the maritime industry. Which slightly drifted away from 3D printing to 3D scanning, and then we will also talk about simulation softwares. We'll be joined by experts like Avinash from Materialize and also Altair to share their insights on the subject. So may I now invite Mr. Vijay to come on the stage, and then probably the virtual stage, and share his presentation. Thank you so much.
So hello everybody, my name is Vijay, and I'm a senior account manager in Faro Technologies, and I look after for laser scanning solution in Faro India for entire South Asia. So today's my presentation will be more towards how we can use laser scanning in shipping industry, where repairs and maintenance is the main areas. And a little introduction about my company. Quite an old company, founded in 1981, and we are a public company listed in NASDAQ, and we are recognized as a global technology company. Speaking about the presence of it, we have headquarters in USA, where we have regional offices in Germany, and for APEC region, we are heading the business from Singapore. In India, we have office in Delhi, and then we have our sales support office, one in Chennai, and the other one is...
Sir, sorry for interrupt. What is FARO standing for?
Sir, Faro, FARO, it's basically the two people who started the company initially. Okay, George Fisher. Okay, the FA words from there, and RO again the other partner, where again the name from the name itself, the RO word is coming. So it is.
And you are based in Delhi or Singapore?
Yeah, I'm based in Delhi, and the whole business of Asia is controlled by Singapore head office. Okay,
I am based in Delhi too, so like to get in touch with you. Yeah, thank you.
For sure, sir, for sure. And if you speak about the sales presence, we have a direct sales presence in more than 32 countries, and again from India, we are controlling business from Delhi itself. Okay, so What do? We have a hardware solution along with the software portfolio. When we speak about hardware, we have a complete portfolio right from arms which can scan small parts, and then we have laser trackers. This helps to align two machineries. I can tell you more details, but today's speci- uh, today's session is more about scanning bigger parts. I will be speaking more about laser scanners. But then on the other side, we have handheld scanners. We have 2D mappers which can scan 2D layout of any building or of any space. And then we have an indoor mobile mapping system which can scan while on the move. Okay. uh, Again, not just the hardware, we have our own softwares to do different kind of things, right from stitching multiple scans and giving you the point cloud data of any specific part or assembly. But then we have our own reverse engineering software. We have our simulation software. We can show you how what all uh, deviations are there inside the part. um, i will I will tell you some of the outputs, and then those outputs do come from our own software. Okay. Now, what application do we, cater? This technology specifically can be used in n number of applications because all we capture is point cloud data. Now, these point cloud data can be of a road or can be of a building. It can be used for a civil engineers. It can be used by BIM modelers where we can scan whole building, and then the point cloud data can be used to create a 3D model. And the other application is in forensics. Many police departments in India, they are using our scanners to map a crime scene, and then the whole scene can be taken to a court into a digital format where the evidence can be secured for a longer period of time. The other is forestry. They are using our point cloud data in different use. One of the major use is calculating biomass of a tree. For that, we have sold scanners in Nepal, and again in India, we are into the process of selling. We'll be getting orders from them also. Then the scanner is used in heritage and preservation. All the heritage in Jaipur, if you speak about all those bigger forts, they have been scanned and preserved. And the department called Department of Design, they have preserved it into the digital format. So let's say tomorrow, if something happens to those monuments, the whole thing can be made from the scratch. Speaking about films and movies, point cloud data is very much useful when we speak about VFX. Movies like Bahubali, movies like Makhi, they in these movies they've scanned small things and then created a larger picture in front of us, and then that is how they're using our point cloud data. The next thing is plant engineering. There are many plants in India where they are old and undocumented. So to do any changes, they need as-built, drawing or data. With our scanners, it can be scanned with 1/10 of the time, and then they can use the data for further work. In survey, again, they're scanning our roads, doing civil surveys, and getting the most out of it. Today's Specifically, I'm going to focus on shipping, how the laser scanner are used by the shipbuilders or by the peoples who are doing retrofits inside these machines. Tunneling, again, using scanners in maintaining the tunnel profile while making the whole tunnel. Those kind of usage, they're using our scanners. Again, for gaming, you can scan any area, use that point cloud data into a gaming station. Again, if you want to model something into a 3D, you need references. For those references, point cloud data plays a very important role in the tracing job. So today I'll be explaining you how you can do 3D scanning, what is the whole idea behind it, and how the data is converted to a 3D model. And for that, whenever we speak about shipbuilding, you know that shipbuilding is complex and it is very much demanding when we speak about manufacturing or doing any changes in these kind of vessels. And all these vessels are quite old. they have been into water since 35 to 50 years. And the majority of these vessels do require changes. And to do these changes, they need some platform, they need some drawings, which many of the vessels lack. And for that reason, they want some technology which can capture things faster, so that they don't have to wait on the ports. So again, if I combine everything, there is a lot of opportunity in it. Opportunity in retrofitting, opportunity in conservation. But the only thing is, they need a rapid turnaround time, and they need a competitive prices, and of course they need much more than what a traditional way can offer them. So how we can win this kind of work? We have to be fast, we have to be very much accurate in what we are delivering. We have to be safe, because it's all complex, and safety should be on the priority. Then we have to be competitive in price, and then we have to offer more to the project owner. If we are onto these points, then definitely we are going to win more business in this industry, and there's a lot of opportunity in it. So when we speak about, we have to be fast, we have to be fast in a way so that we capture everything inside ship. Let's say if you want to do any changes inside an engine room, you need to document everything. And if you want to document everything, you need to spend time inside vessel, and vessel have to be docked, or vessel cannot stop for you, to document everything, and then you work on it to do the retrofitting. Because of this, there there was a need in technology which can scan this thing fast and can document in a quicker way. So for this reason, our product do fit in that space where it can scan any interior, because the scanner can scan up to 350 meters from the source. And within the time frame of 5-10 minutes, it can scan everything which is visible to the lens in 360 degree. Okay. Concept with a touch. Let me show you a small video. This video will show you how exactly it works, and how it captures the point around the machine. Concept with a touchscreen display. It's as easy to operate as a digital camera. The rotating laser of the scanner touches, in the truest sense of the word, its surroundings. The laser beam is used to measure the distance to the object, and together with the device's 2 rotation angle data, determines the coordinates in space. Several million of these 3D coordinates result in a complete 3-dimensional impression of its surroundings. So, if you see, this laser is emitted right from the center of the lens, and that is how it is reflecting back from the object, and the XYZ is captured with this laser. So that is how the things are getting documented, and everything is documented into 3D format. So now, after we capture everything from a scanner, we have to scan from a multiple location, because it cannot penetrate the object. So it has to be placed in a different location, so that every location is covered. And once the location is covered, we have to further process it in our own software called Scene. And the second picture over here is showing you different colors, blue, orange, and red and green. That is showing a different scans that are taken from a different location. And then these different scans are merged to give you a one single output, just like on the third picture. And then this third picture, the collection of points can be transferred to different softwares like Aviva, Bentley, or Ship Constructor. And then further, the 3D model can be generated out of it. And finally, after creating a 3D model, there are a lot of things to be done. And for that, even the data which our scanner is capturing is very much useful. And with that, you can do different kind of analysis. I'm going to show you some of these things, what all things are possible after capturing point cloud data. But before that, I would like to show you the output, the kind of output that is done using our hardware. Okay. So just a short video to show how the data looks like after scanning. Whatever you are going to see on the screen is all points, and I'm just going through to see what all is there inside the ship. Okay. So now you have seen how much detail I'm getting in this video. So if you send any of your engineer to document this kind of place, he will take ages to complete all the dimensions for you. And even if he captures everything, he is going to miss out some information for sure, because there are so many objects to capture. So considering that in mind, if you send an engineer with laser scanner, everything is going to come onto the desktop, and the choice is yours from what point to what point you want to measure, or which section you want to capture as a 3D model. So that is why this technology is very much useful in market. And it says that this technology is times faster than the conventional method what we are using right now to capture as built state of any building or of any container. Okay, so the fast we are in the fast process, which does not disturb vessel normal operations. Like this thing is very important. If a vessel is not sailing, it is actually losing money. So all the ship owners, they want to make sure that the vessel is on dock on a very lesser period of time, so that the operation time do not decreases. So for this reason, uh, people are using laser scanning technology to capture the inside information of ship, and this can be done with laser scanner in a very faster way than the traditional one. Okay, and let's go back to the next part, which is being accurate. Now the data is captured. Everyone wants to make sure the data that we are capturing is accurate. And if you send someone to do measurements with the traditional method, you know that the few mms can go here and there, because the human tendency, if you ask three people to take actual measurement of between 2 points, they are always going to come up with the different measurement. Okay, different measurement means they can be difference. Someone can come and say that this is 10.2 someone can say that this is 10.1 So the difference, you will see that there is a difference. Okay, but when you ask someone to capture using a laser scanner, the accuracy part over here, I'm speaking about plus minus 1 at 10 meters. So whatever we are scanning to an accuracy of 1 So let's say if you want to scan a whole ship, and this machine is going to be used, then the whole accuracy can be maintained within the range of, let's say, 3 which is very very good for retrofits or for doing any changes inside the ship compartment. Okay, so the thing is, like, there is no human factor effect, because everything is captured with the machine, and it is all being taken care by the laser technology that we are using over here. Then complex shapes can be dimension modeled or cross section. Any surface, surfaces are very hard to measure using a traditional method. But if you use such kind of technology, you are going to capture everything in the point cloud format. So whatever curves are there, everything can be measured using this machine. Okay. Then being safe, since this machine is operating from a distance, it can scan right from half a meter to 70 meters, and with the maximum range of 350 meters of the scanner. So if you install it, at at some distance from the object, still everything can be done. And then, since it is using a laser technology, it can scan in complete darkness. So even if there is no lights, with the laser can still travel and capture XYZ and get the details for you. Okay, so no climbing, hanging over pipes, because you can still install it from a distance and still measure the thing. So it is going to be a safe idea to use this machine when you go and measure anything on the site. And then being competitive with others, if you compare it with other with your competitors, you will be more accurate, because you are using a technology to do it. There's no human errors. Whatever is coming from this machine, that is 100% right. There is no human factor involved in it. Okay, and then of course you are spending less time on the boat or vessel, and then since you're using point cloud data, you'll be faster in delivering the output. You'll be safer and you'll use less resources, since you'll be using less engineer to document everything of the site. So if you see all these factors, you will be on the upper side from the competition. And after this, when I speak about what more you can offer to your client, I'm going to show you some of the factors which can give more to your client, and you can win more projects. Okay, the very first one is, this is the kind of output you're going to get. Let's say if you want to scan any ship surface and you want to create a 3D model out of it. So I will just show you one example from one of the customer, how they captured the whole front of a ship, and the kind of output which is coming from the machine. Okay, just a small video for that also. Just give me a second. So in this video, I've shown you the initial part was the point cloud data, and then with the help of software, the point cloud data was further converted to a 3D model of the ship. Okay. The next thing is, so let's say you want to compare from the CAD model, you can use point cloud data and superimpose on the 3D model and see how accurately or accurate your design is at moment. So let's say if you want to compare a vessel after a certain period of time, you can do it after a certain frame of time, and you can check from which part the body is getting deviated. So this is just an example to show you how the deviation can look on the software screen. Okay, this is one more example where you can scan point cloud data, and then point cloud data can be further converted to a 3D piping. Okay, this piping can be from a ship or from any MEP kind of requirement. Okay, just going to show you how point cloud data is now converted to a 3D model. Okay. So this was just a small example to show how point cloud data can be converted to a 3D model when we speak about piping. In a similar fashion, if you want to convert point cloud data to a surface, there is a different workflow. But this specific workflow is done inside AutoCAD using some plugins, which again Faro provide, and that is how the whole thing can be converted to a 3D model. Okay. Now the next thing is, let's say you want to assemble two parts. Okay, this thing we have already tried with Mazgaon Dockyard, okay, MDL, where we scan two parts into a different location, and then we compare those two parts to see whether they will assemble properly or not. So we did virtual assembly and see whether these parts do match perfectly or not. That kind of requirement, you can still use this technology. And then again, if you see over here, no two sisters vessels are like 100% for sure, because there are so many different things that are fitted onto two different vessels. You can compare and make the proper adjustment faster. With the help of this technology, you can actually scan the master ship, and then you can further modify inside the master ship, inside the point cloud data, and then you can plan what the next vessel will be. Okay. Again, if you want to check whether the sister ship is as per the master ship, even you can do point cloud to point cloud comparison. All those kinds of thing is very much possible when you have point cloud data captured from two vessels. Okay. So this is just one example to show you the BWTS retrofit, and in the form of point cloud data. Okay. Just give me a second. I'll just play this video. So just going back, sorry, I was just trying to say something. So on this screen, you can see there's two forms of data. One is colored and one is black and white. So again, the scanner gives us the feasibility to scan surroundings in black and white format or in colored format. But in this, I'm just trying to show you that I have scanned something inside the ship, and then I'm retrofitting it a new system, which is called BWTS. This is the requirement which right now many people do serve in the industry. So in the existing space, new system is installed, and that is how the data will look like. Okay. Now I will just play this video to for you to see the insights of it. Okay. So again, like said initially, the point cloud data can be used in a different manner. It can be used for reverse engineering. It can be used to compare with the actual part, actual 3D model. So there are multiple combinations. You can do clash check. Let's say if you want to do a clash check with the 3D model that you have designed to fit in existing space, you can scan existing space and then virtually install 3D model inside, and then check the clash detection. You'll be able to see what all areas are there which can be a possible clash after the installation. This is done in automotive plants. This can also be done inside a ship industry. Okay. So this is just a small video to show you the fitment part of it. I'll just play this video and then I'll explain what exactly is happening in this video. Okay, now in this, what we are trying to show you that we have scanned the existing facility, and now this 3D model, this is going to move around, and they are checking that whether is there any clash on site when we move this part or not. So I will just now play more and you will understand exactly what is happening. So this is called virtual assembly, I will say, because they've scanned surroundings and then they have installed a 3D model on top of it. So that is how you can plan the new model, how that's gonna fit in the existing environment. Okay. And of course, the data has a long-term value. Today, you are scanning something; it can be used for a different kind of work. You don't need to revisit the site because whatever you have scanned, that is scanned up till date, and what all is there in surroundings, everything is captured as a project, which can be used again and again. Okay. Then ship owners and maintenance crew can online collaborate. We have a tool called WebShare. This tool, a person on the site can upload scans, and the owners, ship owners sitting in different country, or the project owner who is sitting in the different country, he can collaborate online and mention that what all changes are required on the site. Okay, so this kind of platform will definitely help these guys to take a decision faster and do their work on time. These are some of the names of our customers who are using laser scanners. So few of the names. I will now turn one more slide which will show you some more customers. Some of them are from India. Buoyancy, Vidam, these are the companies from India. Integrate, they are also using our scanners. So these are some more names. Okay, and of course MDL, they are also using our scanner. And that is it from my side. Any questions you have, that is my email ID, and please send in your queries or any questions that you have. I'll be happy to answer all of them. All right.
Much, Vijay. I think this actually makes the process faster. So 3D printing being one aspect, 3D scanner is very, very important for in terms of measure and then the construct. And with simulation, I think things are more simplified. So for huge structures as these, in the maritime and the shipbuilding process, I think it does add a lot of value. So thank you so much. And Vijay Chaudhary is also a key respondent with 3D Graphy as a part of the consortium. As ladies and gentlemen, I did mention that 3D technology respondents whom we work very closely are a part of our consortium as 3D Graphy associate corporate members. And that also helps end users to come and look at solutions which can be suitable as per requirement in the process flow. So it's a right way to have something which can be working in confluence going forward to in terms of the offering. Thank you so much, Vijay, for your time and your presentation. And Wing Commander Raman Surupiji, we will have the questions answered, the panel discussion. I'm sure there are a lot of inputs that has already been shared in my handle also. So I think it would be interesting for us to discuss with a very eminent panel that was to follow in the panel discussion. So we would, I'm sure it will be very enlightening. So now let me introduce you to Sushil Mane, who is the director for the technical Altair, one of the leading softwares offering solutions in simulation and software. And thank you so much, Sushil. And they are also one of our 3D Graphy associate corporate members. And I'm sure there's much in the offering for us going forward.
Thank you, Dr. Shibu, for that quick introduction and introduction to the topic. It gives us a great pleasure to be part of this conference on 3D printing and basically in the maritime and shipping industry. We have been involved with a lot of various organizations across different market segments. And of course, maritime and shipbuilding is also one of the key industry verticals that we often work very closely. To begin with, let me share my presentation. Give me a moment. So before I start my presentation, I would like to thank Dr. Shibu as well as the Trinity Group for inviting us for this wonderful conference on 3D printing for maritime and shipbuilding. It is also a great pleasure for us to be part of an esteemed speaker list over here from defense as well as shipbuilding and my fellow colleagues from the other organizations, the participating organizations. So the presentation that I have is basically focused on the software technology with regards to additive manufacturing or 3D printing. And and basically, if you look at Altair has been in this industry of software development and basically product development for more than 30 years now. And we started basically in the automotive segment, but from there on, we have spread across various industries. That includes shipbuilding as well. So let me start my presentation with a few introduction slides on Altair. And here is the Altair vision statement, which was presented by our CEO and founder, Mr. James Scarpa. And it is basically saying that the vision is to basically transform enterprise decision making by leveraging the convergence of simulation, high performance computing, and artificial intelligence. Um, Altair, as I said, has been in this whole software development and design and development industry since almost 30 years. And our focus has been mainly in the simulation side, virtual simulation, as I might call it. And we have been, let's say, not only developing softwares in-house, but acquiring very good technologies across various streams of simulation. And that has helped organizations world across to not only model very complex geometries, but simulate various different physics, very complex physics across different domains. And at the very same time, as the complexity of the models have been increasing over the years, there is a very heavy demand on high performance computing, right? The models are becoming huge, especially if you look at maritime and shipbuilding, and the complexity of the models as well. So it definitely needs high performance computing to not only model such very complex large components, but even simulate for various physics, right? But then over the years, many of these organizations have modeled and simulated and created or generated data of all their simulations as well as tests that they have done on their structures. And with all this data that they have generated, and with the very incoming new technology that we are seeing on artificial intelligence and machine learning, we definitely see that there is a very huge scope of this convergence of simulation, high performance computing, and artificial intelligence coming in together to address very complex problems that customers might face. So it's definitely a very forward-looking vision statement of this convergence that we see between simulation, high-performance computing, and artificial intelligence. As far as the technologies are concerned, Altair has a very broad solutions portfolio. To begin with, if you look at the latest of these technologies that have been introduced right now, from the top left, data analytics and AI. As I told you, this is a very new technology which has come into the play, and organizations world across are trying to leverage this high performance technology in all their product development and various other business decision making that they are trying to do with this technology. So this integration of AI and ML is what we are bringing into the table. And this involves, of course, the entire process of modeling the geometries to running various kinds of physics simulations, right? And that is where the second bucket of the different solutions portfolio comes in. We have various physics simulations as far as capturing all the different types of physics, right from the structural, linear, and non-linear kind of simulations to doing CFD simulations, electromagnetic kind of simulations, and multi-body dynamics, and so on. So these various complex physics have been able to actually help engineers to model all these complex physics and run various kinds of simulations. And to do that, of course, we have the entire design and modeling and visualization tools to help the engineers to read in all these complex geometries and then model them using various FE technologies, right? Apart from that, we have various other technologies like the Internet of Things, all the technologies related to how connectivity can be brought into picture, and all the different systems, the smart products that we see right now, can talk to each other, right? So how we can leverage this technology of having to maintain that interaction between multiple products and see to it that data can be shared across various streams, and we can leverage that data to have a deeper insight on how the products are performing, and then fine tune that or optimize those products, right? So that is about all the smart product development with regards to the IoT. I did talk about the high performance cloud computing, which is one of the core technologies as far as running all these high end physics simulations. And this can either be, let's say, provided as a physical appliance, or the HPC can even go on cloud. So engineers as well as large organizations are trying to leverage this high performance computing by running these complex physics either on the cloud or on their physical appliances. So this is definitely a very useful technology as far as doing all these complex simulations are concerned. So all these different portfolios that you saw are basically coming from the Altair uh, toolkits. And apart from that, Altair has also partnered with various other third-party organizations who provide their tools and technologies under the same licensing brand as Altair. So what customers will benefit is basically not only getting access to the Altair technology, but they can also access the tools and technologies from various other companies, not Altair companies, but other third-party companies with the same license as they have used the other Hypermesh or other Altair-based products. So these are the different solution portfolios that Altair brings to the table. As far as the various market segments and customers, we have a lot of various customers, close to around 11,000 plus customers across various market segments, right from automotive, aerospace, energy, government and defense. That includes even shipping, maritime and shipping, heavy and rail, life and earth sciences, and so on. And it is really a pleasure to really work with all these high-end companies and collaborate with them on solving very complex problems that they come across. So why Altair? If you ask me what are the key things that Altair brings to the table for customers, and how customers can benefit from this, is that we see that there is this best-in-class data analytics and AI that we have with Altair, which customers can really benefit from, having to model all their complex physics, generate all this complex data, and then use the high-end AI and ML technology to create these ML models and use them for all the predictive analytics that they may want to do. So as far as this solution toolkit is concerned, we have the best-in-class solutions which can integrate into any of the customers' data tool sets, right? We have a very global domain and simulation expertise. In fact, Altair started with product design and development to begin with before diving into even building softwares, right? And most of our engineers are coming from various different streams, not just mechanical. And we have been able to not only develop software which is useful to the customers, but also work along with customers to provide product design and development expertise. One of the key technologies that Altair is really well known for is the optimization technology. And right since the early 90s, when optimization was still being in the research mode, it was Altair which actually used the optimization algorithms from the research stream to put it into all the software tools that we have right now. So we could really industrialize all the software technology as far as optimization is concerned, and customers have been able to use this to design their products better. I did talk about the HPC technology. We are also a leader in this HPC technology, and customers worldwide are using our HPC, high performance computing, very efficiently. We are an open architecture solution. What we mean by this is that we are not tying the customer to only use Altair technology. Our software toolkits can actually integrate into any third-party toolkits out there. So this is really beneficial for customers. They are basically able to now use Altair tools along with any other third-party tools, and that is a very win-win situation for customers. And this is one of the core strengths of Altair tools. And then finally, one of the key things out here is the unique licensing model that Altair has. With close to around 50 plus products that Altair has, and each of these different products are all leveled as far as the usage is concerned. They can all be accessed with the same license, and it basically is very cost effective as far as the company is concerned. And this is a very unique licensing model that Altair has, which also, of course, brings in the API products, the third-party products as well. So these are the key things that Altair is really bringing, not only technology but expertise, and that is very beneficial to the customers. Okay, with now the initial introduction, I would now like to dive into the actual topic, and I'll start the presentation with this talk on simulation-driven design. Why simulation-driven design is because for all products that we see out there, the whole idea is to see to it that we design products better, right? And that is as far as looking at the performance of the design, as well as looking at the weight or cost of the design. And not only that, we also have to look at whether those products that we design are manufacturable or not, right? So to look at all these different silos out there, whether it is performance, efficiency, or manufacturability, we need to have a platform which will help us to address all these different attributes, whether it is performance, manufacturability, or efficiency, at a very early stage in the design process. And that is very best, let's say, addressed by using a very simulation-driven design process of having to not only design the products with high performance, but also see to it that at a very early stage in the design process, we also check for the manufacturing feasibility of the design, right? So with this, Altair has come up with a very nice, intuitive, user-friendly platform, which will help us or enable us to do the simulation-driven design. So it's a very powerful and intuitive simulation platform for design engineers to create and investigate structurally efficient designs, and also look at the manufacturing feasibility of these designs. And that comes up with three different, let's say, stages of the design process. To begin with, the first one is to generate these optimal design concepts, right? So the whole idea of creating a very generative design of all these complex systems that we need to really design and develop, we have a platform which will allow engineers to read in, let's say, an initial CAD model that they have, or they can even generate in this platform, run a very complex multi-body simulation, and then extract these loads, these multi-body dynamic loads, and then apply that onto the structural model to now design and develop a optimal design, a very optimal topology design, which will then be used to validate that design, and then we will also check for manufacturability. So this is a very early concept stage development of the design, and it's a very easy to use intuitive platform which allows engineers to create those concepts. Now, after we have created those early design concepts which are lightweight and high performance, we will then analyze that design, right? So in the same platform, we can analyze the structure for various different physics, whether it is multi-body or thermal or structural. We can impose those loads and boundary conditions and then run them for the validation of the design, right? And once the design validation has been done, the next stage is to check for the manufacturing feasibility. And here, within the same platform, we can analyze the feasibility of manufacturing for various different manufacturing processes. Either they are traditional manufacturing processes like casting, sheet metal, injection molding, or whether they are on the new additive manufacturing process that you would want to look at for. So it's a very easy to use, flexible platform which will allow you to check for various different concepts and then look at quick feasibility assessment. So what are these different tools which will help you to not only design the model or the product at a very early stage of the concept, or you can also take it to the final manufacturing, right? So the different tools that are available on this platform are the Studio platform, which is the styling tool. And once you have built the initial styling tool, we can, of course, go ahead to do all the other the modeling concepts. And the first thing that I was talking about is to develop that structure, the very lightweight, idealized structure, right? So Inspire comes up with this concept of doing a structural topology optimization. You can also do, of course, sheet metal topography optimization or size or shape optimization within the same platform. You can, of course, also use the motion platform, which will help the engineers to look at the various joint forces, even look at the motion of the whole system. You can then extract all these loads at the joint locations and then use them for further design validation, right? And once that is done, once the design has been developed, you can then go forward to do all the manufacturing feasibility assessment. Either you can use casting, if it is a casting design that you would want to take it forward to, or injection molding, sheet metal forming, extrusion, as well as additive manufacturing. So it's a very powerful, intuitive solution for design engineers to create very high performing and manufacturable products. In this slide, I'm just showing you the animations of all these different manufacturing solutions, be it casting, sheet metal forming out here, extrusion, injection molding, or additive manufacturing. So with that, let's look at additive manufacturing solution alone. So as far as 3D printing is concerned, now we all know that 3D printing has moved over from being just an advanced capability assessment for prototyping to a final production capacity, right? So it is now finally being used to design and develop or manufacture production ready parts. And what are the different processes which are involved as far as this whole process that we bring to the table is right from extracting loads and the requirements on a particular system. So here is a simple system that is being demonstrated. You can then use those loads to design and develop the early concepts, right? So once that is done, there is a phase where you have to interpret the design and then do the sizing and orientation of the design. And then we need to then use that concept to further go for manufacturing. So you'll have to now go in for a selected manufacturing process, then analyze the optimized design for manufacturability, and then export that final design that you have assessed for manufacturing to any 3D printing machines that you can connect. So as far as the support for 3D printing machines are concerned, we currently support EOS, Rennie Shaw, as well as SLM. So to begin with, I thought it would be good to really understand the early design concept. And here I have a video to showcase how for a certain robotic arm, you can design a new concept, a lightweight concept, which is a high performing design. So you basically have an initial package space of the robotic arm, and then you define all the different manufacturing constraints on the design space that you want to regenerate the design for. Define all the loads and boundary conditions which are basically coming from this multi-body system. Define the problem statement for the optimization, and then run it for optimization. And eventually, as you see here, it has removed material from all those locations which is not needed, and only retained the ideal material layout for given those loading and constraints, right? Once that is done, the next phase is to basically generate that design. And so here we have a feature called as fit polynerbs, which will fit a polynerb design on that concept which was generated in Inspire. So as you see here, this is a very smooth geometry which is generated using polynerbs, which will then be assessed for manufacturability later. So this is the first phase of creating that design, right? Now, once that is done, we will move into additive manufacturing. And here I've taken selective laser melting process. And everyone knows what is the process involved as far as SLM is concerned. So with 3D printing, what are the key things which are important? One thing is part positioning, right? So depending on how the part is positioned, the printing time could be either high or could be quite less, right? So as you see here for this particular product, if it is positioned in this particular fashion over here, we could identify that it would take around 6 hours to print it. But if it is aligned in a different direction, the printing time is around 11 hours. So there is so much of a difference as far as the part positioning of the component is concerned, right? And to really understand how much time it is going to actually take to print at a very early stage in the design process, it is very important, right? So as we are actually generating the design, it is very important to understand what is the printing time, correct? And that is what this technology is really helping engineers to do. So as you see here, there could be, of course, other manufacturing issues that you will have to look out for based on how much time you want to really wait till you actually cut the supports, how much time you would like to, let's say, leave it for cooling. It all depends on how the quality of the final product is. And if it is not done properly, you may end across, let's say, issues like what you see on screen right now. A lot of these manufacturing failures, right? And one such really important functionality is the support structure, right? It is really paramount to actually find this compromise between the support removal time and the support efficiency, right? So that you get the right quality of the part. So where do we need to place these supports, right? So it is very important to understand how you can ideally introduce these supports, have a different kinds of support system. So there are various kinds of support structures that you can lay to actually support these final printable parts. And based on that, you will see a different change in the final product which is manufactured. So here is a design. So the original design was over here, something like this, for a support structure which is shown here. And then finally, by changing a lot of different process parameters as well as the design parameters, we were able to change this design to an optimal design over here, right? So how is this possible? That is possible by actually varying or trying to iterate through various different parameters. One is looking at how the support structure can affect the efficiency of the design. looking at how the part orientation can affect the design. Okay, and then finally looking at how all these different process parameters and the part orientation will introduce different manufacturing defects. There could actually be large deformations in the part based on all the changes in the whole process is concerned, right? Whether you are going to cut very early after it is printed, or are you waiting it to cool properly and all that. So there are many, let's say, all these issues that you'll need to account for. So while you're actually designing this part, how you can introduce all these variabilities and see how you can come up with the right design for the 3D printed part. So here is a process, meaning we have a video which is running on the right side, and these key 6 or 7 steps which are basically involved in the complete process driven workflow as we see here. So the first thing that a designer would do is select and prepare the part, right? So we start with importing the geometry, and once the part is imported, we will assign a certain material to it, the type of material that we would like to use. And once that is done, the next step is to configure the printer. So there are different printers that the software really supports. The first one is EOS, there is ReniShop, and then SLM as well. So the engineers can choose between all these different printers that he would like to use for printing. And finally, he will go to the next step of orienting the part. Orientation of the part plays a huge, let's say, effect on the final quality of the product. And it is very imperative for the designer to look at all the different possible scenarios of the orientation and see the effect of that on the final printed part. So here in this process, the engineer can start looking at various orientations. He can actually change various orientations in this particular process. And of course, there are lots of options here to vary those orientations, okay, either in the X, Y, Z, and even the distance from the 000 location. The next step is to generate the print supports. So once the orientation has been done, the engineer can then generate the support structure. And here again, there are various types of support structure. You can either use a tree support system, a tree-like. There is a pin support system. There is a H-type support system, or a block type. So there are various support structures that the engineer can choose from, and then apply that to the process. Once that is done, then he can preview the slices. So he can go through the entire geometry and then look at the cross section of the geometry and see, preview the slices of the oriented part. Once that is done, he can then export the part and the supports. And then finally, he can run a thermomechanical analysis. And this is basically to look at whether there's going to be large deformation, what are the stresses, what are the displacements of the final geometry, what is the temperature of the final part, and so on, right? So this whole, let's say, workflow of 6 to 7 steps allows engineers to look at all the various process parameters and change those parameters to finally see the effect of that on the final manufactured part. And once he does all that, once he optimizes all these processes and gets an ideal high quality printable part, he can then export it to the machine that he's going to use it for. So what are the key features that the software provides is it basically helps us to generate the support structures as part of the design process where you design the part. It is a very easy to learn environment. It is very intuitive in the sense that it is very icon based. A set of 6 to 7 steps involved in going through all the various processes to not only design the part but check for manufacturing feasibility. He can check for the thermomechanical analysis and see the effect of the analysis on the final printed part. He can look at actually the defects. He can identify the defects like large deformation, excessive heating in the part, any delamination in the part. All this can be observed in the final printed part. Uh, there are various materials that are supported. We have a library of various materials that the engineers can choose from. Um, and then, of course, the three different printing options that we support. And then finally, the export to the final printer, which is ready to print. Okay. So these are the key features. Of course, we have been working with a lot of organizations, mainly in the aerospace, of course, which is one of the key market vertical which has adopted 3D printed widely. But of course, even automotive and many other market verticals are also looking at this technology in a wide scope. So we've got a lot of testimonials from different customers, and here is one of those testimonials showcasing that the software technology is really of great help to them. So as far as this solution is concerned, what are the different competitive advantages that it brings to the table? It basically helps to reduce the manufacturing cost by minimizing the part supports and correcting the defects which basically are typically seen in 3D printing part, especially like part deformation or overheating and all that. It helps in increasing the process efficiency. The single main reason is that it's a single platform, a single software which will help you to not only design the product. A new concept can be easily and quickly generated, but you can also check the feasibility of manufacturing with the same platform, right? And then the whole idea of actually looking at all the different various process parameters and seeing to it that the final um, product which is manufactured can be assessed and exported for the final manufacturing. So with that, what I'll do is I'll probably present another video out here which showcases a very interesting, let's say, combination of 3D printing with digital twin. So here is an example which shows how we were able to marry both these concepts, a digital twin concept as well as 3D printing. So basically what we are doing here is that it's a mechanical system, and by performing this system simulation, we are able to extract all the various loads that come out of the joint locations. And using those loading conditions, we are now going to generate a new concept, a 3D printable concept, and then check for performance for manufacturability. And then validate the performance using the manufacturing simulation. And in this case, it is 3D printing. So as you see here, this was a collaborative effort. Let me stop that. So this was a very collaborative effort between Altair and MX3D, which is an European company, and they have in fact worked deeply on the VAM technology, wire arc additive manufacturing technology. And this particular video actually showcases how they were able to not only lightweight the design using digital twin technology, but also use the final design for doing the 3D printing of that part. I will now come to the last phase of my presentation, and it talks about the material characterization. It is very important for us to understand the material properties of all these 3D printing materials, right? And in more so with regards to all those structures which are lattice structures, right? Because the lattice structures will probably behave in a different way when they are printed. So we have this particular framework, what we call as the multi-scale designer, which will help us to create these predictive material models for all homogeneous and heterogeneous models or materials. The main thing that it basically provides is it helps us to reduce the time and cost associated to material model development. So if organizations are not aware of, let's say, the right material properties, they're not able to get the right material properties as far as running these complex physics simulations are concerned, they can use multi-scale designer to uh, develop the material model and then use it to do all these complex structural simulation to help us to basically look at the design performance as far as weight, cost, and performance is concerned, right? So the first thing is to basically develop a material model and then use that material model for all the complex structural simulation. So apart from, of course, various types of materials, one is these continuous reinforcement materials, which are typically all these composites, as we call them, unidirectional as well as woven type of composites, to looking at even short fiber reinforced plastics, right? Those types of materials, and even additively manufactured lattice structures. These are very complex structures, right? So to really understand the right material behavior, we need to characterize those materials, and this platform will help us to do that, right? So so once you can develop that material model here in multi-scale designer, you can then take that material model for doing all your macro finite element simulations. Okay. Either you can connect it to our own finite element solvers, structural solvers like OptiStruct or Radios, or you can connect to third-party finite element codes like Abacus, LSDyna, or ANSYS. So this is a very seamless platform which will connect to multiple codes. So with that, I finally end my presentation. This was a very generic presentation covering about this software technology. We call it Inspired 3D Print. And it not only helps us to generate efficient, high-performing designs, but it will also help us to check for the feasibility of manufacturing, not only for additive manufacturing, but even other traditional manufacturing processes, whether it is forming, injection molding, and so on. So with that, I end my presentation.
Yeah, thank you so much, Sushil, for sharing your inputs and the insight on how software and simulation can be of immense relevance and importance in 3D printing. That's the reason for this session, which was very broadly, uh, uh, extended to ensure that 3D printing and 3D visualization, including software and simulation, is also a part and parcel, because everything goes hand in hand. While we also understand, topology optimization is the key, and also lactic structure with softwares which can be well, formulated with the print that is expected. And I think there was one, uh, a question that has also arisen is whether this software can also help DED, which I think with this digital twin technology that you shared, I'm sure it's very impressive. So I think that also takes care that area of that would need to be addressed.
Right.
The robotic, yeah. So I think interesting. So there was one the question that we got. Thank you so much, Sushil, for your inputs, and I'm sure it was a great, detailed, presentation with all the inputs that you could share and the solutions that is in the offering. Thank you so much, Sushil. Now,
Thank you.
may I invite Avinash Ibrahim, who is also one of the software experts in his domain, also representing Materialize India, joining from Bangalore, and he's actually responsible for the software solution deployment and also signing up with companies in terms of offering the solution. So you can share your presentation, Ibrahim, to then upload your slide, and then it's over to you. Thank you so much.
Good evening, everybody. I think we've been hearing quite a bit from all the technology experts since morning, and I've been listening to quite a few inspiring stories from different people across the world, especially from Mr. Daniel Dan from Singapore, where I saw 3D printed parts being delivered using a drone from offshore to onshore, which I think is setting the bar too high. As I'm trying to figure out how to share my screen, just give me a minute, and just let me know if you can see my screen. All right. I think I'll keep my presentation quite short.
Yeah, so we have to start at 5. So yeah, so I'm so sorry about that, but
I think apologies from my side because there's some issue when there is important stuff happening. I know there is this Murphy law that kicks in. But then moving on with what we do at Materialize, I'll skip the video part portion of it. But then what we do at Materialize, our core business is software and services. And our software is open and neutral, where the software is printer agnostic. So the software works for any branded printer. If we look at the locations that we are spread across quite vastly across the globe. In the Asia Pac and India as well. From India, I handle the Indian market from India. Bangalore. These are our partners that Materialize works with in terms of customizing or developing software which are build processes for these brands that are there already. In the last 30 years, we've been partnering with the industry leaders in additive manufacturing printers across the world. So what you can expect from us in Materialize, what we do is we have Materialize software, which is one segment which I handle. We do have Materialize manufacturing as well, and Materialize medical, which I will not touch base upon as of now. Although Materialize manufacturing is limited only to the European market, we don't do it for India. Materialize medical is not the forum right now to speak about, although there is a lot of work that is happening, and Materialize medical is quite dear to Materialize as a company. If we dive into what Materialize software offers for the additive manufacturing industry, if we see these four verticals actually complete the software suite for professional 3D printing. So if we are looking at creating the best designs for 3D printing, we have Materialize 3matic. This is the design optimization software where you want to add lattices, you want to optimize the topology of the part in the STL level, you want to add remeshes to your parts. That is what 3matic does. In preparing your files for 3matic, I did introduce you to Materialize Magics, which is our flagship software for data preparation. There are a bunch of other modules as well, but the interesting one would be Materialize eStage, which we'll be speaking about in the forthcoming slides. To get the most of your 3D printing machine, yes, we do offer something called as Materialize build processors, which I mentioned, which goes with the printers that you would probably have as the slicing softwares that will help communicate the STL from the G code into the printers. Materialize Streamix is where you manage your AM production process. For example, where you are already having maybe 4 to 10 printers available in your facility, and then you want to manage your production. Materialize Streamix is one platform where all your printers can be under one software, and then you can manage your production using your additive manufacturing segment in terms of understanding at what time what part was created, for which customer, for which material was used, how much time was spent in the printing of the part. All that database can be managed in Materialize Streamix. Speaking a bit about Materialize Magics, where Magics helps you, like if we recall the phases of additive manufacturing, where the design phase is there, the data preparation phase is there, and then the build processor slicing phase is there. Materialized magics comes into the picture where we are speaking about the data preparation portion of it, where all the files, which is STLs, AMFs, VRLs, SketchUp files, can be imported into Magics. We also have other all imports module, which practically imports any CAD data into Magics to fix the files. Then we have the automatic fixing, we have the semi-automatic fixing, we have the shrink wrap technology, which is very unique with Materialize. All these features will help fix your STLs, which eventually will give you the best 3D printed part, which many of us who understand additive manufacturing as okay, there is a CAD part that we have. We give that as an input, and then we push a button, and then a 3D printed part is coming out. But then in the software that we are having with the printers and in your computers, this is what happens, where the fixing of these standard triangular language formats will be happening. We can edit the files at the STL level itself, where if you're printing your parts as a design bureau and then you want to still make some modifications at the STL level, we don't have to send the part back to the design bureau. But then at the printing stage itself, there are a few design modifications that you could do in terms of making hollow parts, perforations, or cuts at the part. And then the build preparation, the orientation, the positioning, as one of our speakers were mentioning, the orientation of the part is very important for a build to be successful. So these are modules which Materialize Magics has, where with the click of a button, maybe we are speaking about a HP printer, which are large printers, which can carry more than 400 parts for a build. And then one person sitting and orienting the parts, about 400 numbers, will definitely take about 2-man working days. But with modules that we have with Materialize, with a click of a button, all those 400 parts and plus can be oriented in about 8 minutes. We have use cases in India itself where major service bureaus have been using this module called Sinter module, where they have been saving their production times, preparation for production times, to almost 90%. So we export the files again into the build processor, and the build processor moves it into the printer. Right? Like I was explaining about the modules that Magix has, we have very specific support generation modules for metal and for resin-based printers. The replication, as I was speaking about Materialize eStage. eStage is also a support generation module, which is a premium software where it automatically generates supports for a part. So your application engineer need not have a great knowledge on the kind of support and what points of supports are needed at what orientation of part. The algorithm is designed so intuitively that the software recognizes the orientation of the part and then generates the supports automatically. How this helps? This reduces your data prep time by 90%. If we see, we have our metal manufacturing, additive manufacturing facility in Germany. We have about close to 30 metal 3D printers of various brands. eStage for metal was tested in our facility in Germany, and then these were the results which our shop floor additive manufacturing engineers have given us, where the data prep time has reduced by 90%. And then the powder consumption, which adds to your cost as well, reduces by 20%. And the very painful support removal time reduces by 50%, because with eStage you can generate parts which are as thin as your laser spot diameter, which is 100 microns. The most spoken about software module is also the Materialize simulation module. With the simulation module, you can, to keep it in simple words, check if the part is printable or not. If it is not printable, what are the places where the print is failing? Is it the risk of shrink lines? Is it the risk of recoater, coming back and hitting the part because the orientation is wrong? Or is it the total displacement of the part while printing? Is there a change in the part compensation in itself? Or is there the support structure simulation? Support structures generally, for everyone's benefit, not only help orient the part and hold the part at an angle, but also helps in heat dissipation, right? So in the simulation of support structures, if we see the image a little closely on the top right, we can see a red mark where you can see there is overheating happening. So this simulation helps us, the application engineer, to add supports and then help in heat dissipation, which will be helping the success of the build as well, and also the distortion compensation. So these are very basic but very important points which you would need to consider before printing important parts, which would take a long printing time. That's where materialized simulation module helps. I think there was a question by Wing Commander Ramanji about how ideal an AM candidate should have, and then are there people around us who can be, recruited? I would say, to answer that question, these are the modules, or the different kind of knowledge base that an ideal AM candidate should have. Not just the design experience, but then the design for additive manufacturing in itself, because that needs to be part of their skill set to understand, okay, there is a part that can be manufactured using traditional manufacturing concept, which is a subtractive manufacturing concept. But then additive manufacturing, are there upskins and downskins? There are a few things that they would need to consider before either doing reverse engineering of spare parts, which we have been speaking about quite a lot in this forum in terms of maritime applications, where all the spare parts which would have been manufactured using traditional manufacturing, the design for additive manufacturing knowledge comes into picture to understand if the model needs to be redesigned, or if it is being redesigned, what are the principles of additive manufacturing that needs to be added for the topology optimization. That's not just enough, but then the knowledge on materials is also something very important, where which decides the cost of the final part and then the technology that is needed to print the part. So I'm keeping my presentation very quick. I had quite a few things to speak, but then I think the panel discussion is going to start in a bit. I'll keep it short.
Yeah, I'm so sorry, Avinash, because we just start the presentation. We've already overshooted the time. But yeah, I think inputs that you can share subsequently with me. There are, as I mentioned, since we have a consortium, respondents will also be in touch with us. We will definitely want to share those with the team and respondents who are looking at those solutions, and also have a tailor-made session on the subject on 3D software very specifically, could also be looked at as an option. And since you're also one of our key respondents, but we only want to keep up our timeline set in terms of ensuring that, though it was unfortunate, but I'm so sorry about that. Yeah. So we are just getting into this subsequent session in the panel discussion, and do be a part of the session. I'm sure as an audience, there'll be a lot of inputs coming through, and because this is a panel discussion, which will be helpful for us to take the course correction in terms of a pathway set for how 3D technology can benefit the maritime and shipbuilding industry going forward. Thank you so much, Avinash, and we'll keep in touch. Thank you so much.
Thank you.
Appreciate your time and your effort. Yeah, thank you.